1 2 1 2 1 2 1 2 2 1 2 1 2 1 2 1 2 1 2 1 2 2 2 2 2 1 2 One, two. One, two. One, 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 two. Two, two. One. 1 2 1 1 1.
Oh, I cannot work this door this morning. Hold on. There we go. Are you behaving? Yeah. Whatever. Behave, door. Behave. There. Yeah. Hey, morning, everyone. Hey, how was your beer conf last night? Good? Yeah. Oh, coffee. There we go. How are we all this morning? Good? Not awake. Excellent. Hold on. There's no voice on that screen. Well, it's meant to come out of the speakers. Oh, apparently there's a delay on the sound over here, like a 3-second reverb or something. Oh, the TVs are on. Can we get that fixed? Everything's on fire this morning. It's fine, guys. It's fine. Wow, I can actually hear myself now that you mentioned that. All right. Let's just try and power on anyway while they fix that. So, second day of DConf. Now, before we get started, a few things that we should make a note of. Let me bring up my notes. Okay, so everybody, you're aware of your little tags here, right? And you got the security thing on the back. There has been a request to wear them name out, because not everybody knows everybody here. So this is their point of introduction. Oh yeah, hi, I'm Ethan. Hey, excellent, cool. Also, for everybody playing at home, the YouTube stream is now working. Hello, YouTube. Woo! Okay, and now, speaking of our beer activities last night, there is somebody that left something behind. It's a valuable piece of equipment. I'm not sure where else you can get one like it, but there's a bag full of DConf stash. You've left it? Anyone? All right. Yeah. I mean, thanks for ruining my joke, Mike. But yeah, there is more than one. So yeah, stop leaving your stuff around. Take it with you. And if you did leave it, there's going to be a stash of them here. Just find it. All right. I think we're just about done now. So now that we've done that, we can get on with Francesco's talk. Francesco Gala, give him a round of applause.
Is this working? Or can you hear me? Right. So this is the first time for me at DConf, and I'm quite excited. But what I want to report here was the experience of the symmetry outcome of code, which wait a second. Okay, all right. Which took place the last autumn, obviously, from September to December, and involved 3 participants, of which 2 are here today, me and Francesco Mecca, which is sitting right there, and with the objective of improving the ecosystem. I don't like talking about me, but I'm a computer science student. I come from Italy, in Turin. I discovered D while I was trying to expand my experience and improve my knowledge. And I was coming from mainly a C background. So it was a nice discovery, so let's put it this way. And I was also looking forward to contribute to an open source code base, and I was quite interested in start contributing to D. So I discovered from a Google Summer of Code Ideas page, which was 2019, which the D Language Foundation wasn't accepted, that there was this need of HTTP2 in Vibe.d. I don't know if you're familiar with, I guess you're familiar with Vibe.d. How many of you use Vibe.d regularly? How many of you are familiar with the Vibe.http module? All right, quite much. Nice. So there was this plan to rebuild the module, improving it, and in the meantime also include support for HTTP2. So how many of you are familiar with HTTP2? All right, for all the others, I've prepared a couple of slides which are going to be a quick introduction on that. So there are main differences between HTTP1 and HTTP2. The 4 main differences are here, but on a low level, implementation level, there are much more. So the first one is that the protocol is stateful. So you have to maintain a connection state. It is a binary protocol, which means that you have to serialize everything you send and deserialize everything you receive. And then it builds upon TCP to integrate flow control and multiplex various requests on a single TCP connection, which is quite important when coming from HTTP1, because with HTTP1 you have this, for each request you need to open a new TCP connection, and this caused many problems when scaling on a large number of requests. Anyway, this talk is meant to be a report and is structured in 3 parts. The first one being a description of my work schedule. The second one is an experience analysis from the point of view of a participant, which I think could be useful if you need to start contributing with a project such as Symmetry Atom of Code or Google Summer of Code. And the third one is a list of possible improvements which can be actually taught before a probable next edition of Symmetry Atom of Code. So I had to design some milestones which were monthly reports which I had to fill in order to, like, get paid for my work. And the 3 of them are here. There are 3 building blocks, which mainly are protocol switching from HTTP1 to HTTP2, the header completion algorithm, which I'm gonna describe later, but it's based on ranges, and it's meant to serialize the headers of each request so that they take a little space with respect to the HTTP1 headers. And then there's the asynchronous handling of HTTP2 streams, which are just are request and response cycles, which was built using vibe.d asynchronous IO technology. So milestones, what are milestones? Were checkpoints. Each month I had to report to Mike, which is sitting back there, my progress, so that they could evaluate what we were doing and establish if the progress was actually, let's say, on par with what we defined on a previously submitted proposal. So the milestones were proposed by applicants, by us, which had to find a mentor and then discuss with them the possible strategy for the development of the process. So here comes the part of working with a mentor, which is, as at the beginning, some difficulties, has some benefits, but mainly my mentor was Sonke Ludwig, the maintainer of the vibe.d repository, one of the maintainers actually, and we mainly talked about bugs found, about implementation issues, about high-level strategies, and we mainly talked using emails and GitHub PRs, since we weren't very fond of Slack, nobody of us. So one of the benefits of having a mentor when you start contributing to a project is that you can be followed. The main benefit is that you can be followed. The other benefit is that the constant communication flow, almost constant communication flow, can maintain focus, and I found this to be very helpful. Anyway, moving along, my workflow, I'm going very fast here because this is like needed for to explain what went on during the project. During September and October was mainly dedicated to studying and reading and studying and reading, and quite banging my head because I couldn't understand how vibe.d core worked. I couldn't understand how HTTP2 worked, and I kept on going in circles and building my paper stack of things to do, which got like completely destroyed on a weekly basis. Then after a while, I started to wrap my head around it, and Song helped me with that a lot. And so I started with implementing the basic building blocks. The first of which was the HPAC header completion algorithm, which basically it's an Huffman encoding, slightly modified, which can be used to save and serialize headers as they are received, so that the next time you send a message on a request, they take little space, less space, with respect to the first time. This is supposed to be useful, and it's actually quite useful when you have a situation of a lot of requests which are coming sequentially and from the same origin, which it's actually quite often the case. From November to December, I had to devise a strategy to implement HTTP streams, which are request and response lifecycle. So a stream is composed of one request, one response, and all of this happens on the same TCP connection and can be multiplexed with other streams, which means other request and response. The particular thing here is that HTTP2 uses a data dispatch mechanism for which there are separate, it's called frames, but it's a note. If I'm confusing here, you can raise your hand and ask, because I know I decided not to dig too deep on how HTTP2 worked, but I guess it can be pretty confusing from a listener point of view. Anyway, there was a lot of testing and bug fixing and testing and bug fixing going on, and we uses the asynchronous I/O capabilities of Vibe, which are based on tasks. I don't know if you're familiar with tasks, but are basically fibers or green threads, and to implement an efficient strategy, which I'm going to describe further. From December to January, and what is being pursued right now, because we're still working on it, is to complete the review of the last part of the project, because Sonk and I had our commitments to attend to, so it kind of got delayed, but it's there. And then there's some profiling to do and some other testing, some other bug fixing, testing and bug fixing. My point being, after this whole month, when the first time I was able to send a request to the web server and obtain a response, my reaction was this. and I felt like Frankenstein Jr.'s doctor for a while. But the point is, it's really alive, and it's there, and it can be tested. It's on the Vibe/HTTP experimental module, which the plan is to introduce as soon as everything has been ported to HTTP2 capabilities. And so, how does it work? It works pretty much transparently with respect to the previously available HTTP module. In the sense that if you are using Vibe HTTP for HTTP1, the support of HTTP2 comes at no cost of re-implementing anything. Simply, if you receive a request to upgrade to protocol using protocol switching to HTTP2, the flow you need the code you need to write to initialize a web server is the same. If you're using TLS, this is the only line you need to change, because for TLS we are using application layer protocol switching, which is one of the capabilities of the SSL and TLS suites, which allow to negotiate a protocol at the session layer instead of the application layer, talking in Aussie layers. The HPAC module, which is something we are pretty much proud of, is a simple interface of two methods which can be used and are based on ranges. So we are using exceptions right now, so it's not no GC for that reason, but it could be, because all the dynamic memory allocation have been pushed out of the module. It's very lightweight because it uses memory resources. We are following the approach of other web servers, as one of them is Nginx, which is using a static table, quite big, like 3,000 lines of code, and to be more lightweight on CPU and memory, which avoids mainly the possibility of denial of service attacks, which is something that has been explored for HTTP2. HTTP2 message exchanges work by handling multiple HTTP requests, so over the same TCP connection. So that's one great step with respect to HTTP1, and something that needs actually it needs improvement right now, but it's working pretty well. We can comply with flow control restrictions, which are mainly restraints you can put on how much data you can send as a web server. So if my web client asks me, you can send me 800 kilobytes at most, I have to send him at most 800 kilobytes, and then I have to wait until he sends me another message telling me, hey, you can send me another 800 kilobytes. And we can comply with that, which was not easy, but we have done it. And then we are working on enforcing protocol correctness, because the RFC, which describes HTTP2, actually leaves most of the implementation details quite open. So we have means of defining priority between requests, priority between connections, which are actually not described. It's just written there. They tell you, you can define priority if you want, but everyone uses their own approach. So we are working on defining those parts. And what is missing is mainly the last review of stream multiplexing and flow control, which is this, actually. And server push, which is a feature, an optional feature, an additional feature, which was introduced in HTTP2 to allow for a server to send data to a client without having received a previous request. This is quite controversial, but we decided to postpone just because it wasn't part of the actual implementation. And then there's testing, bug fixing, testing, bug fixing. So if anybody wants to help with that, we'll be very glad. A quick rundown of some of the interesting parts, which are not that much technical, because this is not a technical presentation, but we use the ranges as a serialization interface, and they are one of the reasons why I think D was great for implementing a network protocol, because ranges allows us to provide a powerful extraction and write a module which is seamlessly integrates with all the other stream data structure which are part of vibe.d. And we can support custom allocators, which means you don't have to depend on the garbage collector. You can use your own allocators. We have everything templatized on input ranges and output ranges, so you can use this module as a standalone module outside of the Vibe HTTP module if you need to have an HPAC implementation for your own web server. And this is quite easy, as can be seen here, because you just need to provide an encoded source and a destination, which in our case are U-byte stream, a U-byte range, and the structure which describes the HTTP frame header. And there you need simply to provide your table, which is the table I was telling you before, the one which is encoding all the possible requests, and your allocator if you want to use some. I've talked about metaprogramming. This is very far from the metaprogramming which, for example, Robert told us about when he was telling about writing code that generates code. But we exploited some of the features of D to create the indexing table, which is a hash table, which changes both a static table, which is initialized generated at compile time, and a dynamic table, which is built around a ring buffer, and all that while providing a unified interface. So you see we have a static table, a dynamic table, which is supposed to change during the execution because it's supposed to store what has been received. Like in the we're talking about headers, so header name and header values, and those headers are made of name and abstract data type, algebraic data type key, which is made of integers, ubyte, or string, according to the type of header. This was pretty illuminating to implement, just because it allowed us to keep the lines of code to a minimum while providing something which is quite safe to work with, and in which it's quite easy to spot bugs. As you see, we use the same idea which is behind the chain when we were talking about std.range, which is we provide a unified address space while concatenating two of the table according to the index which is provided. So we have all the operator overloading to treat this as an hash table or a range. We used concurrency in a way to exploit the asynchronous I/O model, and we support message passing between tasks. But we built this architecture for the HTTP module, which is made of the event loop, the vibe.the-event loop, which for each connection spawns a task using run task, and passes everything along with the frame header to an HTTP connection handler. This then goes to the stream multiplexer, which is supposed to tell us, is this stream valid? So can I receive the request? Can this request respect the flow control scheme I've agreed with my client, and so on? And if that's true, we have the request handler, which is going to build a response and send the other's response, and then spawn another task, which is gonna dispatch all the data which is needed for the request, which can be an HTML web page, a CSS asset, an image, a PNG image, or whichever you want. And it's going to do that in chunk, because those chunks are what allows us to respect the flow control. As I told you, if I know I can send 800 kilobytes and I have to send more than that, I have to split my data in chunk, then wait after I send the first chunk for the peer to send me another request, which tells me, hey, you can send me another pack of data. And in the meantime, I have to yield control to the event loop. So all this is built asynchronously. And that was what we did. And I can provide more details on that, but I want to focus on the experience analysis, because I think it's important to analyze what went on from the point of view of a participant, so that maybe future participant can benefit from that, and from the point of view of the community as a whole, to see what we can improve on this experience. So if I want to start contributing, and this is very related to what Sebastian talked about yesterday, if I want to start contributing and I see that the symmetry out of code announcement, why should I participate to that? I could participate because it's a great occasion to learn. I could participate because it's easier to start when you have a mentor and when you're followed, and it's easier to gain insight about the dynamics of an open source community, because you get to write to people which are inside it, you get to communicate with them and exchange opinion in a much easier way. All of that while being paid, which is a point I have to make, obviously. So if you wish to start as a contributor and you have one of the following issues with that, so you can decide what to work on and you don't know maybe who to talk to, because you don't know who's in charge of the various projects inside the ecosystem, or maybe you have no experience and you're afraid of not completing your work, there are some things you can do which can help you a lot. The first one is that if you can decide what to work on, you can just go to the DConf wiki pages and gather some ideas from there. They list a series of possible useful projects, and for example, mine was on the GSOC 2018 ideas page. And for each project, there should be a mentor assigned. And I think this can actually be improved, and we're going to talk about that. But it's a great starting point. If you don't know who to talk to, there are the many communication channels, and I have an edit there after the Sebastian's talk because he can explain it way better than I did. But you can post on the D forum, you can ask on IRC or Slack if you prefer Slack. You can write a simple proposal and send it to someone and say, hey, I want to start contributing. And where should I start? Sonke Ludwig actually did it for me, and it was very, very nice to talk with. And the third issue you can have is that if it's the third time of your first time, sorry, of tackling a huge project, you might not know where to start, and you might have little understanding of it. So I don't know when to start from documenting myself. I don't know where to start from understanding the internal logic, but also the development process. And this is why there's a lot of time to be spent reading at the beginning. At least it was for me. So my first message is never be afraid of reading, actually. And in my case, I had to read a lot of stuff because the RFC are quite long and can be quite frustrating. But it's quite easy to wrap your head around the project. There's pretty much well-documented code on Phobos, except for maybe some modules, but it's not a topic for this talk. And also for Byte.d, there's pretty much of documentation online from their website. And then there are similar projects which one can turn to. For example, in my case, I can have a look of other web servers implementation and reason about their strategies to, let's say, take hints. And then there's the community itself, which is pretty useful in that regard. Then there's mentoring, and mentoring is the key when you want to kick off your experience and start with a good rhythm, you know, because as it was the case from this year, one of the participants found some difficulties which he couldn't cope with, and he had to leave. He also had less mentoring help because his mentor was found later because of a turn of events. So one thing you could do if one situation like this come to be is communicate and let your needs be heard. So going with notes from the future, which I think are the most important part of this talk. These are geared towards the community, because when I come to reason with the help of Francesco, which is sitting right there, about what our experience was and how it was organized, how it was planned, we decided that it could be improved in some ways. So we know we have some benefits. We know we can spread the usage. We can push development of the features using a project like Symmetry Atom of Code for the simple reason that it brings new people inside the community. We know that if you have a fresh eye on a code base, it would probably find a new perspective on it. So fresh eyes and minds might solve bugs, which is something which shouldn't be overlooked. And as I said, there are benefits to that, both from the participant point of view, then to the community members' point of view and the foundation point of view. But there are risks, because in a project such as Symmetry Atom of Code, if it could happen that participants drop early and don't finish the project, and that's a waste of resources mainly, and a pity actually. It might happen that the work which was planned in advance might require more time than what was decided to be. So, for example, in my case, I have to say I'm a little late. Yes, I am, because the milestone review which we had to complete for the beginning of this year is still going on, and that is not due to us, than to all the commitments that the mentor had, I had, and I guess it's not easy to plan in advance those things. Also, we have the introduction of new feature with the Symmetry Atom of Code or Google Summer of Code projects, such as HTTP2, which have a risk to be orphaned If the participants decide to leave after the experience because they did their work and they got their money and they're running with it, maybe, or simply they get tired and they're not satisfied with the experience, it might happen that the new features are left there. There are quite some examples of this. Well, one of that, I think it's the XML module on stdd.experimental. So how can we improve that? We could build something like a desert switch, but that's not the point. The point is that we have to do, in my opinion, 3 things. We have to increase communication a little bit. We have to improve means of gathering of ideas, especially because sometimes the wiki pages are not sufficient, sometimes they're not updated, sometimes they're not what they're not all that could be. And we have to determine if and when an actual project comparison between the participants is needed. So, communication issues. We didn't have much communication issues, but it is true that there were few of us. We were 3, then we came to be 2, and but we saw that if one mentor decides to be busy 1 month, this can cause delays on milestones, and also if the participant has some other schedule for that month, this can cause delays. And if a participant is in need of help because his mentor cannot help him, or maybe he cannot provide all the knowledge he needs to use, there's the need to someone. And one thing we can do about this is to encourage participants to document their progress, so that other people can jump in and help them, knowing whatever they did in the previous months or days or weeks of work. To quantify an impact of a project for a participant is also quite difficult because, for example, in my case, I don't know which impact it's going to have on the community. I mean, HTTP2 is quite useful if you have a large number of requests on let's say enterprise-grade web server, which needs to serve heavy content. So a lots of cookies, a lots of dynamic web pages, which exploit the multiplexing over a single TCP connection, exploit the fact that you can control every little bit of what is sent and is received. But if you have, let's say, a static web page, a blog, maybe, it's not that useful. So what's the impact it's going to have on the community? I guess that is to be seen. But if with proper communication and with proper reporting, maybe on, I don't know, on the forum, on the IRC channels, of what is being done, maybe the community can provide more insights and more advices about what has been made and what is there to do. Another thing is about encouraging to post on the forum. We weren't really encouraged to do that. We weren't neither forced to do that, and I have to say I didn't do that, and I regret it. I should have made my progress more clear, maybe, just because it could be useful. It could have been useful to have some more insights about what we were doing. And I'm gonna publish with Mike a blog post about this, and so that we can discuss it more. But the aim of it is that participants might need to be motivated, and not just through the money or the fact that they are contributing to an open source project, but through the fact that their project seems and actually is useful. And sometimes I think they need to understand that from the community directly. The other thing I wish to concentrate about is that fostering ideas from the community is not that clear if we're coming from outside the community. Like, we have a series of dlang.org, wiki.dlang.org pages which kind of left unmaintained. Like, I don't know, we have project ideas, which is there, and it's been there for a long time, but I feel like nobody is looking after it anymore. We have a wish list, and if I'm coming from the outside and I say the wish list, I might think, hey, something in there is useful. something is there needs my help. But then the last history commit is was 2015, so I guess that may not be updated. There are the language design discussions, which also are quite past our time, and there are a lot of projects which could be updated, could be removed, or I don't know. For example, let's take Calypso. Calypso is at a development stage which is way further what is described on the wiki, and I think this is about who's working on. It's an objective of who's working on Calypso to update the lang wiki, but nevertheless, this may lower the quality of the information we have there, and this could also make other pages seem less I don't know, worth of trust when you're deciding what to do and how to do it. So my suggestion here, and it's something which can be worked on, is to put some effort in maintaining one reference page, which can be periodically refreshed and cleansed of new ideas and old ideas. Can be easily reachable from the dlang.org website, because you don't want someone who wishes to contribute to have to navigate through the whole wiki to find that. With the objective of making contributors autonomous, so that they want to propose an application for the Symmetry Atom of Code or the Google Summer of Code, they simply have to say, oh, there's this page, I go here, and I check the mentor, which is associated with a proposal. It might not be a mentor, it might be a maintainer, it might be someone who's responsible for that, it doesn't matter. But I think it could be very useful as a reference for planned and desired work which is needed in the community. Then there's the last point I wish to make, and I don't know, how am I on time? Can you give me ahead of time? Thank you. So the last point I wish to make is that project comparison can be difficult. We found ourselves in the situation in which one of us was to be awarded winner of the Symmetry Atom of Code project, and our first reaction, at least my first reaction, was winner for what? And because our project were different, he worked on a garbage collector, I work on an application level protocol, because we designed our milestone. So we decided how to work and when to work on it. We communicate in different ways and with different frequencies, and add some kind of different development process. Mine was mainly write code, then submit a pull request, and then Sonke would tell me, oh no, you can't do that, you better do that other thing. And there was this review cycle which took a bit for each milestone and pull request, and there were about 15, 16 pull requests submitted of my side. So while Francesco, and I'm sure he can explain it better than I did, but Francesco has a lot of email exchanges and very few pull requests open, because it's his code base and his changes he has to submit was way less than what I had to submit. Anyway, how can we judge two different projects? And it's something, it was not very clear to me, and it's not very clear. It wasn't very clear at the presentation of the Symmetry Out of Code either. So we have to base on some objectively measurable quantity, which can be how many lines of code have been written, or how many pull requests have been submitted, how much he posted on the forum, or he or she posted on the forum, how much he exchanged emails. And so I gather some data, we gather some data, and well, this is what Francesco's did to make you understand that the difference between my work and his. He can explain it better than I can do, but he had to study a lot, he had to design a lot, and the point of this, he had to work less code than I did, but it surely took him more time to write that code. So as you can see, we have two main differences there, which is that he exchanged a lot of emails while I exchanged very few. He wrote very few lines of code with respect to mine, but I think it can be said that I wrote very few lines of code too. And when I realized that this data was actually telling nothing, I I told myself, well, I cannot measure to, I cannot compare two projects like that, because there are different, and there's a balance in which you have to work on. For that, if I have my project, my actual implementation time required and mental overhead and such was way heavier than the time spent discussing it, because I have everything laid down on an RFC. I had a whole lot of documentation. Well, if you have to work on the runtime or something low level, it turns out that the actual implementation time, it's way less than what you have to put in discussion, in design, in benchmarks, and after that, maybe profiling and considering if your contribution can be integrated properly. So what's the point? What's the point in comparing two projects? And I tried to reason about that, and I think that's a point that needs discussion. What's the point if you possible aims could be to strengthen competition so that each participant works more, and they work more because they want to win something. They want to win something, and they want to be awarded to be the best. But is it actually needed for project completion? I mean, if you are from the point of view of the community, you want something like this because in my personal opinion, at least, you can introduce changes and you can introduce new people inside it, and changes which can be used, which are useful and solid, or become solid with time, actually. But none of the competition that could be enforced is geared toward project completion. To me, it's all about careful planning of what work has to be done, to ensuring mentors are available and willing, but I guess we have plenty of them, fortunately, and to consider interest and proposals over technical preparation, because that might not be a requirement. But the most important thing for me was that participants must document what they do, because it might be that the work they did gets lost because they did it their own way, because nobody else is going to pick it up after they finished, and because they maybe don't have the time or the resources to finish. So I think one of the possible improvement is not necessary to enforce competition between participants, but it could be that enforced documenting and reporting and a little more planning time could benefit the project completion. So to conclude, because I think I'm almost out of time. All right. Symmetry Atom of Code has been a great occasion for me, because I can be here and it's very exciting and it's the first time. So, by the way, sorry about my English. No, it's not that bad. But and it can be an approach to starting as a contributor, which is an alternative to doing all the work by yourself, which can be tedious, can be difficult, and sometimes it's just better to be followed on the first steps. But it needs more guarantees, in my opinion, that the work we did is useful, and that it can be used and exploited after the project finishes. So, thank you. If you have any questions, I'm pretty happy.
All right, so raise your hand if you got a question, anyone. There we go. First question. All right, Sebastian's on it.
About your Vibe HTTP implementation, is there a plan how to implement the HTTP to push API?
Yeah, as I said, there's a plan, but we decided to postpone it because mainly because it's not actually necessary for the correct function of the web server. So if you need to focus on something right now, is to complete an efficient strategy for stream multiplexing, and then maybe to implement a proper way of deliver large files, which are another part of the issue. After that, we are planning to work on that, because we saw that there's a lot of requests and desire for that feature in particular. So it's gonna be there. It's just I cannot give you an ATA on that at the moment.
Cool. Anybody else?
I had my breakfast. I don't bite.
All right, questions going once, going twice, 3 times, that's it. Give it up again for Francesco. All right, before we have a little break, you may have noticed we've had a bit of a schedule shuffle. The updated time slots are available on the Announce forums and the D-Lang website. Go check it out if you want to know what's going on. Otherwise, back here at 10 a.m. for the next talk. Okay, everybody. Roll back, roll sitting down. Okay. Oh, there they go, off to their seats. Hello. All right, there's a rather involved discussion up there with Walter and Andre and everybody. We're about to start again, guys.
Okay. I just want to note I still only have one monitor available. Is that correct?
Oh, you should have. Well, that's all up to your display there. Like, you should be able to get that.
Right. But I'm saying I'm just seeing one HDMI output. Is that correct?
One HDMI output. Yeah, that's fine.
All right,
Yeah,
because
these
I thought those were separate.
Yeah, no, this monitor, and that monitor match.
Oh, okay.
Yeah.
All right.
All right, we've got
gonna be a
those
bit
little
interesting.
issues sorted out now, I guess, and we're almost ready to go. Yes. Okay, everybody, it's on time. Hooray. And over here is Matasphere. Take it away. Applause, applause.
Thank you. Almost got the name right. It's all right. Hello, welcome to DConf, which is kind of a silly thing to say on the second day. Excuse me, I'm a bit nervous. I'm going to be talking about the way that we develop software at Funkwerk. We've been writing D-based software for coming on 10 years now, and I like to think we have gathered some experience with the, not exactly optimal, with a rather effective way to combine the features that D offers into a development approach that is appropriate for writing sort of a semi-microservice-based architecture without running into the plentiful pitfalls that D offers when you're going in the route of long-running services. First of all, a bit of introduction about what exactly is Funkwerk, who exactly are we as a company. A lot of you arrived here by oh, I'm sorry, I'm standing in the way. Apparently, I'm being told. A lot of you arrived here by train or by tram or by underground rail, and you may have seen an announcement that a certain train was delayed a few minutes because it missed the last station, or five stations ago, it got a bit of a blocker on the rails, and it can't be there in time. So you have to take the replacement bus. That is what we do essentially. The entire chain of data flow in this, from the point where the train measures that it's delayed, from the point where it doesn't realize, where the station realizes that the train hasn't arrived yet, to the point where you can actually see that information on the display. This is passenger information, and this is our competency. So usually this is not the case that we control the entire chain of data flow from train to display. Usually it's the case that the customer has their own sensors at the train station, or the customer has their own displays. And so we need to speak with one in a rather large variety of possible protocols. And so in that sense, basically our job comes down to taking in data either directly from the device or from one of a large number of interesting and hilariously outdated protocols, and transforming it into a unified internal domain format, doing some processing on it and handing it out again in the format that the customer expects and that the display expects. So for 10 years, approximately coming on 10 years now, every new backend component in this chain that we've written has been in D, largely D2. So this started out in a place where we were coming from Java, essentially. Rather, we were basically, we weren't entirely comfortable with this new language yet. And we wanted to be sure that if it turned out that D was actually secretly really terrible, that we wanted to be able to switch back to Java or switch back to something similar. So our initial code was really, really Java-like. So to the extent that we actually generated classes from a UML template, so we could potentially switch straight back to Java if need be. This was not a good idea, even at the time. Basically, if you're having a very long-running service and you're reading gigabytes of XML of external data, and you have to pass that, and you have to transform that into an internal format, and every single XML node is a class, and all of them reference the class above them and reference the children below them. Let me put it like that, we bought a lot of memory. It was definitely not unusual to see processes in the single or very low double-digit percentages of gigabyte. Furthermore, rather demonstrating the point that from the start, classes should really have been non-nullable by default. Every single member of those classes had an invariant that checked if they were not null. If we had a constructor, we checked parameters if they were not null and start. If we had a function, an accessor, we checked if the result was not. There was a lot of boilerplate going around. The further problem is that what we ended up with is already we were trying to go for a microservice architecture. Like we didn't want a monolithic heap of code. We wanted something where you could work on different components at different times in different teams. The problem is that we were still extremely stateful. Like every time one of those components started up, it had to talk with the services that was trying to interact with, and it had to get to bootstrap its state from these services. And there was a lot of bootstrapping involved. It is not unusual even now for a starting service to take half an hour. That's not good. It's really not good, especially if you're supposed to be agile. Furthermore, we ran into a problem that we really didn't use in significant amounts of const yet, primarily because, again, coming from Java, there's no const in Java. So we had a lot of distributed code that changed state in a lot of different locations. It was not easy to understand what that code was doing at times. So over the past 10 years, we've tried to gradually switch to a sort of proper, better style of doing things. And I'm going to have these slides in the talk with the exclamation mark. Those are my rant slides. Sorry, my respectful criticism slides. I'm trying to give some pain points that we experienced and really highlight where I think that D could be better. Now, when I'm saying D is almost too powerful, this seems like praising with faint damnation, essentially. And this is like, powerful is good, right? A powerful language is something you want. The problem is that D is so powerful and D is so generic that you can write D in a C style. You can write D in a Java style. You can write D in a C# style, even if you want. The problem is that if you write D in a Java style, you're going to suffer, essentially. You're going to run into difficulties, and these difficulties are only going to reveal themselves after you have already invested a potentially very large amount of time in writing in this style. In that sense, specifically if you're running with, like we did, Java like D with long-running processes, the garbage collector, especially on 32-bit where we started out, is going to hurt. Now, the thing is, it doesn't have to be this way. Like there's good D in the sense not that it's good code, but in the specific sense that it works with the advantages and disadvantages that D has, that it avoids the pain points. And furthermore, this is also D that looks good. This is also, if you're using ranges, if you're used to using ranges, this functional style, it's very elegant, very impressive. And I think specifically, there's a code style guideline for D, but there is no development style guideline for D. Like there's no sense that if you look at the documentation, there's no sense in general of the pain points. Like there are open bugs in the language that have been open for many years that are completely undocumented in the documentation. In a certain sense, the documentation likes to pretend that everything is all right. I think that's a mistake. I think specifically the documentation could say this is a weak area. If you want to be safe, you want to write long-running process, you could avoid this. You should write it in this or that sense, this way instead. Like push structs, push ranges, push no GC. Especially if you're having developers coming from Java, this is not obvious. This is very much not obvious, and I think it could stand to be documented a lot better than it is. Coming back to our problem. So we actually have a dedicated architect, and this dedicated architect had read recently about domain-driven design. And this was a very good thing for us, because domain-driven design is an architecture that really synergizes well with D. Now, the problems that we ran into were the plentiful use of global state. And the thing that we did to address this was we tried to very much compress state into a small number of objects, and a small number of classes in particular. So one way you can do that is you can try to write your code in a way so that it's impossible to change state, or that it's impossible to have idioms that change state, except in specific points of code. You want to concentrate your state changes in a smaller layer of code as possible. Furthermore, we've tried to split our code apart into areas of competency, into going by which domain area this code was relevant to, and then actually do hard enforcement of the separation between those layers. The way that this works is, oh, there was supposed to be text in there. Okay, we have some additional font problems. It doesn't matter. No, it's good. It's good. Okay, so this works. This is pure domain-driven design. The idea of it is that fundamentally you're splitting code approximately in 3 layers. So you have the protocol layer, which concerns itself with the interactions in between services and the outside. Basically, every time you have 2 services talking to one another, or one service talking to the network or talking to a customer, this is protocol. Control is state change. Every algorithm, every state change is on the control layer. And model, which is a bit weird, is just your domain. Like the definition of the data in your domain is in the model layer. And the model layer is a lot more important than you give it credit for. I'm going to go into that in a bit. The important part is that protocol can see everything, control can see model can't see anything else. Model is pure. It's isolated. And furthermore, usually when you're talking between domains, we don't have that completely internally, but usually you only want data flow in one direction. Basically, when you're looking at this area of code down here, when you're looking at model, you don't want to have to think about anything else. You don't want it to be possible to think about control. You don't want it to be possible to think about protocol. So this is actually hard enforced in our system. We're using the depend library, which one of our developers has written. And this is a framework where you can actually, well, the ostensible purpose of it is to generate UML diagrams of package dependencies in D. But the beneficial aspect of this is that you actually have to specify your dependencies up front. And when your project violates the dependencies, you get a very nice audit error in your build system, in your, And you actually get warned, and you have to explicitly opt in to any dependency that isn't already specified. Right, so these 3 layers I mentioned are important because they're different. Like if you're looking at the code in those layers, it's completely different code. There's almost no similarity. And just a sketch, okay, at the protocol layer, you have state, but all the state is state from your framework. For instance, you have HTTP state, you have JSON RPC state, you have whatever XML, JSON, XML RPC state, there's a bunch of options there, but you don't have application state. You don't have anything about your domain. For those who don't know domain-driven development, I want to throw in here for a moment that the domain is everything that is business logic. Basically, when you're talking about trains, you're talking about domain. When you're talking about requests, you're talking protocol. So in the control layer, the second one, this is every bit of domain logic, every bit of business logic is concentrated here. And specifically what it does is all the state changes, all the algorithms on this layer. And the model is pure. The model is stateless, which means that nothing in the model mutates anything. Nothing in the model holds any state. The model describes state, but it doesn't mutate it. What this comes down to in D in practice is specifically at the protocol layer, we are taking heavy advantage of templated, boilerplated code. As this leads to something called a naming protocol. I'm tentatively calling it a naming protocol. Basically, in an internal service, it doesn't have to talk to anything complicated. It just has to talk to other services in the same architecture. Protocol is basically empty. It's just code that says, I'm connecting to a server on this domain, this port, and it implements this interface, and that's it. All the rest is generated. All the rest is framework code that you don't have to write, you don't have to worry about. Now, the thing at the control layer, I'm just sketching this right quick, is at this point, because all the mutation is concentrated here and because you don't need the protocol to set this up, control is isolated from above. Again, I want to clarify this. In a usual service, if control needs to send a message to another service, it has to do a protocol call. It has to say something like do an HTTP request to that service. We don't do that. We don't talk about HTTP in the control layer. This is basically, we're using something called dependency inversion, where the control layer specifies what sort of calls it wants to be able to make. And it usually does that in form of a class. And this is essentially the only place where we use classes. Basically, the control layer says something like, I want to make a request of this domain. And it does that by specifying an interface with a method. And then the protocol layer implements that interface. Because again, the protocol layer can see control. Control can't see protocol. The protocol layer implements that interface and then passes it in when it instantiates the control structure, which makes it very easy to write feature tests because your tests don't have to worry about the networking. They can't worry about the networking. Now, at the model layer, this code again looks completely different. We have essentially only structs and enums down here. Basically, this is effectively plain old data. We wish it was plain old. It isn't plain old data, but it's effectively plain old data structs. That is, structs that have no private state. They're semantically immutable. I wish, again, they used the keyword mutable, but they can't for reasons I'll get into. And they heavily use disable this. Everything down here is domain state. So disable this allows us to avoid it even being possible to create a struct that doesn't fulfill its invariant. Right. Oh, that's the wrong direction. All right. Now I'm going to have a bit of a rant here about structs as value objects. Now what we want is immutable. What we really, really want is to be able to say nothing in here can change state. You can only return a new value. You can't mutate anything, especially because everything in those structs could be public. We want it to be public. We want the domain level to be transparent because we're not hiding anything down here. The problem with immutable is that it doesn't work. It doesn't work with reduce, with group, and most importantly, it does not work with associative arrays. Associative arrays are the single most useful data structure if you're writing domain logic. You need associative arrays, but you can't have them. Because associative arrays have to do assignment to a key under the same name, potentially in the same data, and if you're using immutable data, that's, nope, can't do that. You should be able to do it, but you can't do it. So essentially, with that single inadequacy alone, immutable has become completely unusable for us. So what we actually, once we thought about this problem, and we said we don't actually care about data immutability. What we care about is semantic immutability. We care about that you can't construct a value as a struct and then you mutate it, then you make a change. So what we actually used was private, which goes against the entire point of the model layer. You want everything in there to be transparent. So what we're doing is we have private fields, and in every assignment, in every instantiation of a struct, every array that goes into a private field is stubbed. Remember how you complained about the garbage collector? Yeah. Okay, this was not nice, but it was necessary. Every time you read from such a field, and it's not a const tree, it's not declared const, it has to be dubbed. So again, you have effectively an immutable field. You can't mutate it from the outside. You can't mess with it. You can't break it. The other branch of this is that we're using a lot of invariants to encode like business dependencies, something like a train, the journey between stations has to contain at least one station, stuff like that. And again, this is enforced by the fact that you can't mutate data in the structs, even though it's not invariant. We don't like this, but we have to do it. So here's an example for how this code actually ends up looking. Now this used to be quite painful. What we used to be able to have to do is we have to private int array underscore, private array, and then we'd write an accessor for it. We would do public array of int array, and make it const, return array, this array underscore dub. This was horrible. So luckily what we changed to was this rather elegant, if I may say so myself, which I may not because it's my code. It's very improper to say that. It's UDA, very user-defined annotation, which basically just says generate me an accessor. And later on generate me a constructor, and generate me a toString, and generate me an opcompare. This is everything of this is abstracted away. You basically just have to tell the system what sort of automatic methods you want in there, and they're provided for you, which is convenient. So basically, using the information, the constructor generate this doesn't just generate a constructor. It also generates information that says what sort of fields the struct needs to be instantiated with and what sort of field can access. So essentially, we're taking the struct and we're making its members private, and then we're doing workarounds to make them public again. It's a bit silly, but it works. Certainly compared to mutable, it actually does the job. Right, I already mentioned a bunch of that, so it's going to be quick to get through here. The huge advantage of having protocol as a separate step, as a separate wrapper around the entire domain logic, is that you can swap it out easily. Like we're using REST calls now. We didn't used to use REST calls. We used to use largely JSON RPC calls on standing connections. And switching from JSON RPC to REST was easy. It was very easy. Like if we had written our domain code embedded in a protocol where you'd actually explicitly make REST calls or explicitly make HTTP calls, you'd have to change all of that and you have to solve all of that around. It would have been painful. Due to the fact that control is a thin wrapper outside it, protocol is a thin wrapper outside protocol, switching to REST was very much easier than it would have been in a more embedded protocol. More embedded framework, I'm sorry. Now, here's actually a huge advantage that is not obvious. The fact that all our model data is transparent. That is, you can enumerate the public fields, you can enumerate all the properties, and you can see their types, you can read them. The advantage of this is that if you have some domain data that needs to be passed to another service, all of this can be generated. All of this is generated. You just call it on the protocol layer, just call encode with your value, and it's automatically converted to very, very trivial JSON. And again, because it's structs, you don't get into problems with loops, you don't get any sort of recursive data structure issues. You just get a very, very clean JSON format that you can just dump on the network and decode back. Now, a huge point of this is that we don't use classes in model. But there's one use case where you traditionally use classes, and it's when you have a field that wants to be one of a set of data types. Essentially what you would traditionally use the visitor pattern for. Don't use the visitor. Please don't use the visitor pattern for domain data. It's bad, it's wrong. What you want to be using is, not sure if I remember this, algebraic data types, right? Where you want to be able to say, like, I have one of 5 different types, and I want to have one type that encapsulates all of them. Because the entire point, again, what's the point of OOP, of subtyping as compared to composition? It's that you don't know what your types are going to be. You don't know what elements are going to be going into this possible set of data. But in this case, with the visitor pattern, then you say, yes, I do know. Yes, I do know. It's this, this, and this. And I want you as a visitor to be able to be called with all of them. You're essentially turning back around. You're saying, I'm going to take this one advantage of object-oriented programming. I'm going to throw it away. I'm going to discard it. That's pointless. It's silly. Don't do it. What you instead want to do is you want to specify, I have this type, I have this type, I have this type. And then I have a composite type that can be one of each of them. Right, just so small side trick there. Going back to the actual talk, at the control layer, this is where the main point of this talk comes into play. When I said process-based object orientation, what I specifically mean is that at the control layer, we don't use classes to model state. You don't use classes to model business entities. We use classes to model business processes. What I mean by this is that when you're asking a question like, when is the train going to arrive at a station? You don't have a class for the train. The train is a struct. You don't have a class for the station. The station is a struct. Because this is all limited state. What you have a class for is the question, like the analysis of trains at stations. Train station state, for instance. The advantage of this is that you're using very thin layers of object orientation. The only reason to use object orientation here at all is to abstract in between domain slices. For instance, if you have protocol A on the left side, protocol B on the left side, you only want to specify an interface of these sort of questions you want to ask of a station. And then on the other side, you just inherit that, and the protocol layer puts it all together into an application structure. So you just worry in each slice about the sort of, you implement the sort of APIs that the other parts of your program may be interested in. The advantage of this is that there are very few points where state can change. State can only change in the process classes. So your threading becomes very simple. Your synchronization becomes very simple because you only have to synchronize at those points where state can change, and those points are just the process classes. Essentially, we are not afraid of threading. Usually, we have a lot of threads going around, and we have a lot more deadlocks than we have corruption issues. We have basically not had any significant corruption issues for coming on a year now, as far as I can remember, because it is very easy to avoid corruption with this model because you're not changing anything except on those 1 or 2 points which are wrapped in synchronized blocks. Cheers. Right, I think I already said that. Right, and a useful side effect of this, another useful side effect is that at the control layer, you basically have those few classes that implement the requirements that you're exposing to other layers or to other slices of your domain, and everything else is functional code. Like, this lets you use ranges very, very, very heavily. We basically use ranges exclusively. There's a designer once said, I think every for each is a bug, and he reviews with that in mind. If you're writing a loop, he slaps you on the hand. It's like, why are you using a loop? Use an each, use a map. It's actually really good because you're avoiding a lot of possible bugs that way. Basically, every time you would usually get into inconsistencies in your data flow, you usually get a compiler error instead. It's very nice. It's actually surprisingly memory efficient too, because surprisingly many range operations don't actually allocate memory. This is, you'd think that functional programming would run into memory problems, would run into uncontrolled allocation problems. It's actually much cleaner because you don't have to create arrays all the time. You don't have to create appenders all the time. You can just build up your transformation and you can say, okay, just crank it. Just crank this chain of ranges and you'll be happy. You get your data out at the end, and then you create your new state, create a new model state, and you can synchronize in one go. Makes testing easier too. Apropos synchronization, time for another rant. Synchronized is a good idea. It's a very nice feature. The idea is you have a class, and you can just mark it with synchronized class. And what this does is basically every method is synchronized, and every public method is synchronized. And when you call the method, you automatically grab a mutex and you do all your invariant checks, and then you go into the main code, and this is shared. Why is it shared? We don't know, because the problem with this is the idea of shared is that you're looking at data that may be in view from multiple threads uncontrolledly, essentially. And everything that is not directly under this, that is referenced, for instance, arrays, has to be shared in the current D approach, because maybe this array that was passed in from another thread. Maybe the other thread is going to mutate it. You don't know. You can't know. The problem with that is we don't want shared. We really don't want shared because it doesn't do anything. Shared is at the moment pointless. What it does is it's a semantic annotation. It just says this code may be visible from other threads. You should think about it. And you have to say, all right, I thought about it. It's not visible. I'm going to cast that away. We don't want you to use cast. Cast is a sign that the compiler hasn't understood what we're doing. Cast is a sign that the compiler, we don't trust the compiler. The compiler says you can't do that. We say, yeah, I know, compiler. I want to do it. It's okay. It's okay. But that's not good. That's not good because you don't get checks. You're losing all your checks. You're using all your type checks. You're losing all your constancy checks. If you're casting to another type and you're casting away shared, but you're also casting away immutable, for instance, and you don't notice, the compiler doesn't tell you. It can't tell you. So we don't want shared. We don't. On this one case alone, we've basically eschewed the use of synchronized classes, but we still needed synchronization. So every single control class that changes state has methods using synchronized this. The problem is now our invariants are completely boned. It's hopeless. It's completely hopeless. Let me give you an example. So this is how you would technically have to write code if you wanted to synchronize this in a method. For instance, you have a value, and I'm going to pretend I wrote private in front of that. So what you usually want to be able to write is invariant value greater 0, just as a trivial clean format. The problem is that it's not synchronized. So you have to write invariant synchronize this assert value greater 0. And then in the decrement, you do the in condition, etc. This is redundant with the body. Ignore that. This is just an example of an in condition. Usually you check a parameter, of course. And again, you need to synchronize. And in the body, you need to synchronize the actual state change. And this still doesn't work. Let me be clear, this still doesn't work. The advantage of doing it this way is you don't get data corruption. That's all you're getting. You're not getting any sort of safety. You have a chance, you even have a good chance of catching invariant violations. If you only have one thread running at a time, you're still catching your invariant violations. But if you have two threads, you can check your invariant, and then you can check another method's invariant, and then you get into the body, and you've completely lost track of if your invariant is actually true. It's very hopeless. But the problem is, the advantage of doing it this way is you don't have to worry about shared. You don't have to do any weird casts. And it's very much a situation of pick your poison. And I think that the point of this is that we don't care about shared. We straight up don't care. We know we are in a class, we have private fields. We know these fields belong to us. We own that state. We own every method that mutates that state. We don't care about shared. We care about authority. We want to be able to say, this is our data, this is owned. Nobody from outside can write any data to it, but we can. This is not the same as immutable. It's not even the same as const. You want to be able to replace the data, but we want to be able to say we can only replace the data with data that in turn be owned, and we can't hand it out. And at that point, if you're having a synchronized method, it doesn't need shared because it knows that it's the only one that's writing the data. Just something to think about. That's where you want to be. That's not where D is at the moment. But it's something that we wish that would be kept in mind when thinking about the shared rewrite. So to summarize this, we're way below time. I've been talking way too fast. All right, whatever, you're gonna have a longer break. So in summary, at the protocol layer, you can take very much advantage of the fact that your model is transparent, your model is plain old data, it's readable. Everything on the protocol layer can be generated. Everything on the protocol layer can be swapped out. It's very nice. On the control layer, this is the layer where object orientation, process-based object orientation comes into play. You have a small number of points where you change state. You have functional algorithms, you have range-based algorithms, and you have very coarse state transitions. What I mean by coarse is that the state of your program changes in one go. You go from one valid state to another valid state. On the model layer, using declarative typing, what I mean by declarative is using these user-defined annotations. You're using read annotations, very, very, very seldom write annotations, and using invariants to guarantee that the state of your program matches what you're expecting from the domain, that you get an error if you try to construct anything invalid. So in the classic object-oriented sense, you have classes that model entities, that model relations between entities, and that manage the mutation of the entity. In object orientation, the state doesn't belong to anyone. The state is public. Then, sorry, I put that wrong. The data is public. The state is owned by the control class, and it is updated in the sense of the way in which it's updated. The methodology is decoupled from the actual state change. This is the range-based logic. And in summary, you get an object-oriented architecture. You use a very flat object orientation. You use declarative data types and use functional algorithms in order to improve your expressiveness. All right, that's it. Thank you. As a final page, we have I have a link up for the boilerplate generation for accessors, constructors, to string, etc., and structs. I have a link up for a dependency visualization and checking framework. And by the way, we are hiring developers. If you're willing to move to Munich, we're very much looking around for that. There. Thank you very much. Yo, questions?
Yes, it looks like we've got 20
Mike,
minutes for questions, so get asking, everyone.
I was just wondering why the control layer uses runtime polymorphism instead of compile time.
That is a very good question. I don't have a clean answer for that, but the background of this is that we've been somewhat tentative in introducing templates. Like, we originally started up in very much a Java framework, so very much an object-oriented framework, and we have introduced templates in an isolated way. We've introduced templates to handle the modeling, the user-defined attributes. We've introduced templates to handle the protocol abstraction. We have not gotten around to thinking about templating at the control level yet. It's definitely a valid idea. It's going to make testing a slightly bit more difficult potentially, but it's definitely something that's possible.
Thanks.
I had a question about how the problems you ran into using garbage collection in classes. So
Yeah.
for those of us who haven't run into these problems yet, could you walk us through, like, what did you observe? How did you discover this problem? What should we be on the lookout for?
Right, that's a very good question. And that's something that I really should have used more time to explain in the actual talk. So basically, the problem was that we, as a company, very much grew into the level of data where we ran into trouble. Basically, originally when we started out, we did not have any difficulty. We had problems, we had processes maybe using a few hundred megabytes, and we were very happy like allocating everything, absolutely everything all the time. But then what happens is you deploy that code to production and you don't worry about it anymore. You just leave it running. There's no significant bugs. You may make a few fixes, but the code grows, it grows and it grows on. And at some point, you notice that your process has now run for 2 weeks and it's up to 2 gigabytes. And you still don't worry because it's normal. That's okay. You have the memory for that. The problem is that you never really notice a point where the memory use becomes obvious that your fundamental design pattern has been crippling. You don't run into a hard wall. You just run into, okay, maybe this is using a bit of memory. I should allocate more memory to the virtual machine. But the thing is, we could have from the start used ranges. But this is very much something that you're not going to run into if you are writing D in a way that isn't dogmatically focused on classes. essentially. If you have a development methodology where you're already open to using ranges, where you're already open to using structs, where you're already willing to say everything that can be a struct will be made a struct, you're basically not going to run into that issue unless you actually have the amount of data to justify this amount of memory use. This is really something that we ran into because we decided that objects were fine. We can use objects all the time, it's okay. And then at some point, it became less and less okay as the amount of domain data we had to worry about grew, and as the amount of time that processes were running grew into days to weeks. So this is very much something that snuck up on us and that we only realized in hindsight.
On a related note, wasn't there an issue with a network interruption that was caused by GC collections?
I don't actually know that. It's unproven. Like we have an ongoing bug at the moment where we have some long-running tasks that you are now using WebSocket connections in order to deliver notifications. And sometimes, like maybe once a day, maybe we are running into connection losses essentially. And we don't know why that is. I actually know if this is the same problem if you're talking about, but it's definitely something that's affecting us acutely. And I think what may be happening is that we set the timer to 3 seconds. And you'd think 3 seconds is a lot. But if you're running 3 gigabytes of memory and you are under CPU load, and you're running on a virtualized machine where maybe other processes are also stealing a lot of CPU time from you, it is not automatically impossible to me that you can hit the timeout by sheer coincidence. Your process can just go away for 3 seconds and not come back into user code until the time is already passed. I don't know if that's the case, but it's very much possible. So that, all I'm saying is give your networking code generous timeouts. It doesn't really hurt you.
You talked about that you were thinking about microservices for your architecture. Did you actually use that?
Yeah. From the start, we used a network of interacting services over network connections between Docker containers. And the way that this works out in practice is that we have a separate folder that is reserved to specifying interfaces, essentially. That is reserved for specifying state that needs to be shared between a service and things that talk to it. And this is actually handled by Git submodules, so you literally pull in that actual folder. It's convenient. Now, the point of that is that on the side that needs to talk to it, on the protocol layer, you just instantiate you just instantiate a client. On the other side, you just instantiate a service. So this makes it very easy to bring up 2 services that need to talk to one another, can talk to one another in a straightforward way. And on the control layer, a REST call between 2 services looks exactly like a call between 2 domain slices. There's no practical difference. Now, where we started out was with a model of microservices that was a bit too big, where we had very, very monolithic, not exactly microservices. We basically had services. No way it's called micro. And we ran into difficulties with restarting them because we had a lot of active state in each of the services that needed to be restored on every restart. And that made our application very inflexible because it still takes a lot of time to bring those services up to an operational state. Now, we are trying to switch to proper microservices, but it is my impression that we may have gone slightly too far edging into nanoservice territory, which is very much unpleasant. And even with the small amount of boilerplate we still have a lot of infrastructural boilerplate to bring a new service up. And I think that does hurt us in that sense. So we're trying to find a happy medium there, but it's very much a transition in progress.
You said you had memory problems when you had your processes running for a long period of time. Did you actually identify whether that is simply that you're building up a lot of memory that you're using, or is this some problem with false pointers or leaks or something?
There are 2 separate issues that we ran into. The first one was an architectural one that we ran into with our XML modeling. Specifically, the issue was that every time we read an XML file, we wrote it into a class-based data structure where we had in each node of the XML tree a pointer to all children and a pointer to the parent. Now, yeah, those of you who know data structures and garbage collectors are realizing the problem now. And there are always going to be some false pointers in the program. The issue is with an architecture like that, with a tree layout like that, every single false pointer anywhere in your XML tree holds the entire tree alive. Everything connected to it, all the all the text data that you've just read is everything, all of it is alive. That was painful. So a lot of that overhead went away when we switched to manually freeing every XML tree after we were done with it. But we could only do that because we didn't keep any XML state alive past the point where we had done the parsing. And this is another benefit of the separation between protocol and control. Because by the time you're done with your XML tree, you're done serializing it into your application, you are really done. You can very much be confident that all of that can be freed. And that is very much an advantage that we took advantage of to reduce memory use. A second problem that I'm not sure about, that was never properly debugged, but that I have my suspicions about, is D does not have precise stack scanning. It is going to take a while actually to get precise stack scanning. And I think the issue why we had false pointers, and again, this is a suspicion, this is not guaranteed. I think what happened is in a multi-threaded program, you have somewhere in your call tree, you have a pointer to your XML tree. And this is an address on the stack. And maybe that function returns and then it calls another function, and that other function happens to be using a line data, for instance, and it has a hole in the stack frame at that point. So at that stage, your pointer is never going away while the second function is running, and that can be a very long-running function. It's just going to hang around literally forever, and it's going to keep everything in that XML tree alive forever. And at some point, maybe that function is going to return, and maybe that field is going to be overwritten, but this is not something you can really count on. And D is not at the point where, if we had accurate heap scanning and if we had accurate stack scanning, that would not be an issue. And I think we would then be at a point where we could actually be confident that everything that can be freed will be freed, but D is not at the moment there yet.
I guess you could zero out.
Yeah, that's actually what we ended up doing.
On the way out and see if it changes.
That is what we ended up doing, and that did help. The problem with that is that we didn't keeping that code because it is very much weird code and it's very much needs to be documented a lot. And we actually didn't end up needing it after we decided to manually free the XML tree at the point we were done with it. So, but it is very much something that we tried and that did help.
All right, we have a question from Discord here. Jin Shil asks, how is Funkwork managing language changes such as deprecations, and what is their feeling about gradual language changes?
I am so glad you asked. Okay, first of all, we are very much trying to keep our services at a level where everything is relatively current. We usually pick a compiler version. The last one was, I think, 282.1, where we're confident that we're going to take this version, we're going to stay at it for maybe half a year. And we're going to play around with newer versions if we need a specific newer feature. And we're going to try to get our library code up to date to the new versions as soon as possible. But generally, we're going to keep most of our services at a level, when we don't have a problem, we're going to keep it at the level and we're just going to keep going with it. But usually every half a year or so, there's a service actually I've written for the company where, because every version is tracked and every version that we're pulling in is in a universal format. Like, for instance, we have DAP, or we have Git externals, or we have some other specification files that define how we are pulling in additional dependencies from the Artifactory, for instance. And all of those let us enumerate how many possible versions there are, what the current version is. So there's a page you can go to, and you can straight up look up what service is at what level of updatedness. You can see if a service is outdated because it's going to be marked in a very angry red. And it's basically going to tell you, the way that works is, whenever you're making a change to a service, that service moves to the top of the queue. So if you're looking at the front page of the service, you're going to see, all right, this, and this service has been recently changed, and it's very outdated. Maybe you should bring it up to date, hint, hint. And I think that we try to push developers to say, when you're making a change to the service, if it's not so outdated that bringing it up to date would be more painful than actually making the change. And that does definitely happen for very old services. But if it's not too outdated, the first thing you should do is bring everything up to the current standard, run the tests, see if everything works, and then do your actual domain task. So this is definitely something we're very aggressive about. About the second half of your question about language changes, we are hurt so much more by bad features than we are by changes. If there's something in the language that is hindering progress, that is causing ongoing bugs, please, for the love of God, change it, break our code. We want you to break our code if it's in the interest of making the language better. Please, very much please. In my own interest, by the way, anytime you decide to remove alias get this and nullable, I will buy you a beer. I don't even drink beer, I will buy you one. That single bug has cost us so many hours. If you're ever worried about removing that because of legacy code, please, for our sake, don't.
So I see you used shared. Do you use it in production? And if it weren't there, would you be unhappy?
Are we using what, please?
Synchronized.
Oh, we're not using shared. We are very much avoiding the use of shared, primarily because we're scared of it.
I was speaking about synchronized.
Oh yeah, synchronized in production. I'm sorry, could you repeat the second half of your question, please?
Do you use it in production? Question one. And would you be unhappy if it weren't there?
Shared and synchronized and specific. That's a hard question. We're using synchronized to the extent that we are basically using it as a wraparound mutex lock and mutex unlock. If it were not there, we would have to go back to explicit supertypes with automatic mutexes, which is something that I think with the proto object was already considered. And this is very much a transition that we would very much, not exactly like to make, but we would very much be open to making. And the problem with synchronized is that I'm not sure if a scope-based solution is more legible. Synchronized this in specific is a statement that you can very much see what it does. You can very much see what amount of code is covered by it. And if you're using a scoped struct, for instance, a scope autolock, for instance, this would be more convenient to write in certain sense, but very much harder to understand. So I do think there's value in being able to write a declaration that just is to say this block of code is covered by a mutex. But that is not inherently something that needs to be in the language as a dedicated statement. I think, for instance, if there was a version of with that called a function on entry and called a function on exit, that would be very much an adequate replacement for us.
All right, are there any other questions? Nope, nothing. All right, then I guess that's everything. Give it a round of applause. All right, so we got about 15 minutes to the next talk now, so enjoy yourselves. All right, come on, guys, come on. In you go, excellent. And, turn around. All right, we're good to go again. Okay, just one little thing before we get going. I've had somebody ask for IRC and Discord details and all that. I will post those in the announce forum on the D-Lang forums. So if you want to get on and ask questions that way, I'm tracking Discord and IRC. So you just tag my nickname in there and I will ask questions for you during question time. Okay, with that out of the way, we can turn it over to Lewis. Talking about compile time types. Give him a round of applause.
Hi, thank you. Some of you already know me from previous years. This time I didn't have to come very far. Currently, I'm living in Cambridge. So if some of you are here in the UK or want to have a little nice trip, maybe want to hang a bit, drop me a line. I mean, to be cool to do some DConf or other cool projects. Maybe I can provide even a place to stay for a few days or something like that. Okay, so today I'm going to be talking about compile time in D in general and how, in my opinion, it could be improved in some ways. And I think compile times could be perhaps be a solution for some of those areas for improvement. And this is still very early concept. So I'm prototyping some of these ideas, but I felt like perhaps it would be worth to present my initial direction. I felt like you could give me some feedback on this, but they are very speculative ideas. Still, it was kind of, to borrow a line from Linus, in the spirit of present early, present often kind of thing. So I really expect you to be very skeptical of what I'm about to present today. So it's me, it's not you. Your sanity is still there. But even though I expect heavy feedback, if you want to provide feedback and ideas and different approaches, that would be very welcome. So what's the issue? Have you heard about the Peter principle? Yeah, quite a few of you. The idea is that in an organization, you are promoted until you reach your level of incompetence. And this is a management concept, right? Where you're like this really good employee and you're doing good work. It's like, yeah, let's promote you. And you keep doing good work and yeah, let's keep promoting you. And then suddenly you're in some kind of management position, don't really know what you're doing. And now you're stuck there because you're not going to be promoted, you're not going to be down more towards whatever it's called. So you used to be such this nice and productive employee, and now you're stuck doing something you don't like and nobody likes what you're doing. And this is kind of a metaphor that can be applied to a lot of things in life and maybe even something like D. So D was introduced as kind of this alternative to C, and let's do kind of like a little thought experiment here. I want you to picture like a typical C code base. And it's a pretty reasonable language despite its flaws. I mean, some parts of it are pretty okay. The basic stuff like functions, structs, things like that. So there are some problems like with the types, undefined behavior and so on, but the basics are pretty reasonable. Certainly could be improved, and D improves on a lot of them, but it's pretty okay. But then there are other parts of C that are like a complete train wreck. And I just focus here on the preprocessor because it's like, I really hate it. Like headers, including them, the dependencies, all of their effects, having to define concepts as like preprocessor defines and macros. It's like, man, that's like the worst idea ever. All of the problems that come with it, not respecting scoping, the unsafety of the lack of having to put parentheses around stuff. It's like completely brain dead. And when you use D as an alternative to that kind of C-like programming, where you use like C-style code, it's really nice because you take all of the bad parts, like you had to define constants, now you use like enum constants, you add like these ugly macros, you replace them with functions that can be inline, can be templates, so on. We have all of these nice modules. And it's really, really nice. We had these two disparate languages, the C preprocessor and the C language itself. We replaced it with a much more cohesive whole. And the experience is, well, this meme, in my opinion, it was invented to describe the experience of programming in a C-like fashion. Sure, sometimes you'll have like vulnerabilities and so on, but it's just so pleasant to like, you hit enter, 100,000 lines of code get compiled in 1 second, and things just work. They are super simple because you write very straightforward code. It compiles super fast. You don't really use these very advanced concepts. So even a beginner can understand the code base. If you really have hard problems, you can just use a few of the more advanced features here and there. It's really, really nice. And I think sometimes it's nice to like just do that little experiment and do that kind of programming just to see the other side of life. But I feel it's really pleasant. Anyway, so if this is so good, and this is like, oh, the good old times. You're like, what do you mean good old times? Like before we had anesthesia? Yeah, don't think about it too hard. See, if this is so good, then why rock the boat? It's because you don't really want to program in C, because you want these really nice features like ranges and introspection, generic algorithms, safety, no GC, immutable traits, all of this nice stuff. The problem is that sometimes that doesn't really work that well. And let me just clarify here. I imagined I'd be presenting like to a very D-centric audience, but I know some of you guys here don't have too much experience with D. So this is all very relative. I mean, D on its worst state is still better than Java and that nonsense. So that's very relative. But you know, there are some problems. When you use some D features, the compilation can get really slow. You get these annoying error messages that are hard to understand. Sometimes you change one part of your program and something seemingly completely unrelated breaks the other sides. You have these weird features that you're not really sure how they should work and how they should interact with other features. And it's an experience that may not be the most pleasant. And that's like, well, yeah, D has been promoted to its level of incompetence. You were so happy using all of the basic features, and they work really well because there were these improvements upon C, like all of the bad stuff had been removed and replaced with something better. But you just had to open the box, and you just had to use all of the new features. But then you get stuck with some of these less well-defined behaviors and these not as pleasant programming experience. So why has this happened? Well, there's not one straightforward answer, but I think part of the problem is that D just has amassed a lot of features. And there's a lot of terrain to cover. Not all of the features interact with each other as well as they should. Not all of them are as well specified and implemented as they should. There's always a lot of things to do into improving the language. And even features which sometimes in a fundamental way are just dealing with the same underlying concepts, they deal with them in different ways, so they kind of clash with each other. They have like different perspectives on how things should behave. Also, another thing that I believe sometimes happens is that when you program in this more modern D style, the way the D language works and the kind of approach we're trying to take, I feel that D, as it's currently defined, may not be have the most appropriate programming model for how we want to program. And what I mean here is that, well, I'll talk about that more in a minute. So I have this feeling that, like Strup said, like inside C++, there is this small, elegant language struggling to get out. So I ask you, is there like a more elegant language trying to come out of D, like this very beautiful core? And I believe there is, although in this talk I will focus more specifically on the compile time features. So how do we get to that essential core of the D language? I think there are two major ways of improving D. One of them is the way that's done most of the time, and it's a completely valid path, where it's this iterative model. Just pick parts of the language that could be improved in some way, don't have all of the nice properties that they should have, and you iterate on it. You provide a compatibility path so that you can keep using the old approach. You transition to the new approach. And here we have things like constructors, which you've talked about yesterday, things like the proto-object efforts. I think it's also a very nice work that's being done there. I think this is great. But for some of the more fundamental issues like this big language, maybe this isn't quite the right model for what we want to do. This may not be the most appropriate approach. And I believe the part here is that this is a really big language, but we don't have like a huge community. So it's not like we can unleash this legion of programmers and go like to these committees, specify all of the intricacies of the language like C++ does, like all of these proposals, and they battle it out, and then comes like a 1,000-page PDF that really specifies all of the different corner cases. I think our long-term strategy must be in terms of simplifying the language and finding common core features that we can build the other things upon. And so this is more like a research project, and I mean here research not necessarily in a sense of academic, but that my idea is that sometimes it's worth the effort to like do a little pause, think things from scratch, like not be necessarily concerned about compatibility in the long term, just explore an idea like if there were no compatibility objections, how would we really want to do this? And then once you explore that without having some kind of blinders on, you think, okay, I see here what's really fundamental. How can I then backward to the current production D? All right, so what should the core D features be? I think modern D revolves around a lot of compile time, and this is mostly two aspects. It's the introspection part, where you look at the code that's around you, and you see what its properties are, and based on what you see, then you do code generation. So this is a bit like object-oriented frameworks in the sense that you're no longer in control of like the main function. You generate code that will interact with this ecosystem. And you do something very similar, but like at compile time. And I feel it's very important that these kinds of activities, since they are so central to modern D, they should be very natural. They should feel like just regular programming for like runtime stuff. They should be very accessible to beginners and so on. So what is compile time? Well, it's not a single thing. I mean, there's a lot of different uses that we have for it. Some of them are computing stuff at compile time, so we don't have to compute it at runtime. Others are like metaprogramming, generating other programs, just choosing which parts of the program we are going to compile, which flags, things like that. And so we have very different uses for it, but in terms of also the implementation, they have very different implementations. And this often leads to a lot of accidental complexity where the different parts, they don't really agree on a common model. There's this interesting article online on the D Wiki talking about compile time versus compile time, because especially new programmers indeed tend to have this idea of what compile time is that's not quite correct. And you can see that indeed there are two fundamental compile time notions. There's a notion of the AST building level, which is like kind of the templates, the static if, and that kind of stuff. And then there's the compile time function execution. And the problem is that they are kind of disconnected, and sometimes people don't really realize that, which is something that this article addresses. You should totally read it. So the AST manipulation doesn't really have access to the complete semantics of the program, while the compile time function evaluation doesn't really have access to the AST manipulation. So they exist in completely different worlds, which explains why people will sometimes ask things like, why can't the compiler read this value at compile time since it's clearly known at compile time value? So for instance, here we have this compile time function, and we have a static if, and we are looking at this b parameter, and we know that this b is true because there's this true value specified there at compile time, but this won't work, of course. And if you're familiar with the intricacies of these languages, it will be like totally obvious to you, and you're like, why is this even an issue? But the problem is that there's no clear mental model for someone who's just coming to this stuff. And it's very easy to, if you're already very familiar with D, to disregard this and think that that's not an issue at all. But I believe it is. I believe there's something fundamental here which is being confused. And there are sometimes examples which trip up even more experienced programmers. Like in this example, we have a function which receives this array of arguments, and you do a for each over them, you do a static if, and then you have the continue for the for each. And so you're thinking, what does this print?
All the types and not an int every time.
What does it print, sorry?
Like not an int at every iteration.
It prints not an int on every iteration.
Yeah, and when it is an int, it also prints that this is an int.
Right. And this isn't super obvious to someone who's not, doesn't have a lot of D experience. So read the article if you don't understand why this is the case. Moving on to a different example, this should also be pretty easy to someone who just got started with D. So what does this print? Okay. In function of int, it's pretty easy. What does it print now? Wow, I thought Attila would know this, be like, this is super trivial. Yeah, I know. Yeah, it's not a function anymore. So it prints void, which I'm not even sure makes sense, because it's like void is a type. A template doesn't have a type. So it should just not print anything or give out an error, being strictly speaking correct about types, like type theory and that kind of stuff. So why does it print void? Well, because that part of the compiler doesn't know anything about templates. It doesn't see templates. But I think this is problematic because it's totally reasonable to think what the type of a template is. There's nothing fundamental about this decision of that part of the compiler not knowing about templates. So perhaps this is the design that we actually want. So what's a type? A type says useful things about our programs. It says what something represents, what its possible states are, and what operations you can do with it. So I ask you, is this something reasonable to ask about a template? No?
It has no type. The question doesn't make sense.
It has no type, but couldn't it have a type?
No. It has no data, it has no state, it has no operation. You can do all these at the same time.
So the argument is it has no state, it has no operations that you can do with it. Well, I disagree. I think it has operations like you can instantiate. That's an operation. The type can tell to you what do you need to instantiate it with. The type can tell you what do you get back because different templates return different things. Yeah.
For like a simple template with for like simple implied templates like a class or a struct or a function, what you're saying makes sense, but a template can also be like a block and you can define many things inside of it. Maybe I'm just not seeing what you're saying.
Yeah, I think the summary of the question is like, well, this is a really hard, tough issue because it's like a template could just return so many different things. It could be like a struct, but it could also be like a block, right? So how do you make sense of that? Well, that's why I say that this is very out there. It's like smoking a bit of weed, thinking what's really fundamental about this. But on the other hand, there's like so much potential. Maybe if we can answer some of these questions, then we can unleash all of these different potential that's there in the language.
Well, it's not really. I understand what you're saying, but templates aren't types. They're kinds, though. I mean, your example with foo was kinds, type to type. It takes a type and then it returns another type, which is a function.
So Attila basically is saying, you can't do it because I guess it's a function. Well, a function has a type, so I guess it kind of makes sense.
Order
It's a
Yeah.
higher order type. So
Yes.
so it's kind of a type. It's a different kind of type.
Yes.
It's a type of types. So higher order type, kind of function. So it turns out, well, it's like, it doesn't make any sense. You start, but then you're like, well, it could be this, it could be that. Well, maybe it's worth thinking about it. So I could go away to right now. It's like success. I've got to start thinking about this. We already have some success. So still being on the wondering about these characteristics of templates, we have discussed what its type should be, although we haven't arrived at the conclusion yet. We can also wonder what exactly the semantics should be. And these are these areas of the language that aren't quite very well specified. So for instance, there are issues of when exactly is the template specified? So issues of ordering, because a lot of the language is declarative, but then you instantiate templates in those declarative contexts. So what happens when you have things that you will be able to notice? Yeah.
When I was thinking of templates, I was thinking a little bit of like JavaScript closures. So if you have a template and define like 3 functions and a struct inside, in some ways, a template is kind of like a compile time environment in which you can define other things inside, like types. And you can have like a chain of nested environments that fully describe the type.
That's interesting. Yeah, I could see that. So it's a kind of compile time environment, something where at compile time you do stuff. And yeah, I think I could work with that. We'll get to that. If I don't address your issue, then please ask me again. I'll try to understand it better. So in cases where there will be side effects, we'll have to really be mindful of what the semantics of the ordering are. And also in terms of how many times a template is instantiated, what are the semantics that want to be there? Not what currently are in D, but in general, like the best possible world. D was designed from scratch with the best possible design. What would we really want it to be? And currently, we have this cookie cutter model where it's like this, I don't know, this kind of cookie shape. And then we create it several times. And this isn't really always the most appropriate model. And you can see, for instance, these with the typedef template, where you have to pass this cookie parameter. And this is kind of a hack, because it's like we say that if you instantiate a template multiple times with the same parameters, you'll get back always the same type. But then in other times, it's like, well, that's not really what I want. So I'll just pass another fake parameter just to disambiguate and say that I got back different types. But maybe that could be an opportunity to revisit, is this actually the semantics that we want from templates? Maybe we want to sometimes get different times even though we pass the same arguments. Back there?
I have worked with this problem a lot, and the thing is, templates do pretty much have to stay the way they are, but we could introduce another system that has more functionality that you want, that allows you to specify what types of type operations you can perform and stuff.
Okay, that sounds, let's talk about that. That sounds interesting. Okay, so what about the semantics of what you get back? I mean, you have, in a template, you generate stuff, like you don't return a value, right? But we often use templates to basically get a value back. So we want function like call and return. And so we have this so-called eponymous strip where you assign a member of the template, the name of the template. But this is just a symptom of the model just being broken in some way that doesn't really do what we want. So we got this kind of workaround. But we got so used to it, but we kind of forget this kind of, in a sense, ugly and very arbitrary. And it's interesting because this reminds me of another language where you assign something to the name of the function to set the return value. You know what that language is? Basic, right? Yeah, things like Visual Basic, things like that. And that's generally not considered to be like a super popular design decision, but we have basically the same thing here, right? And then every time we do one of these decisions, like, oh, it's really cool, we don't want to actually access a member of the template, we actually want to get just like the return value of the template. So we'll introduce this trick of the eponymous naming the member after the type, and that will totally work and solve the issue. But then we introduce all of these complexities, such as, well, what about the other members? Should they stay hidden, or do you want them to still be publicly accessible so that maybe that's useful in other types? So it's like, oh, well, I guess it's useful in some contexts. In other contexts, it's not useful. I don't really know. We punt on these decisions, and all of these garbage tends to accumulate. And they're not very significant by themselves. Then they all start interacting with each other and have this big ball of mud. So that's why I think it's important to really reevaluate these decisions. And there's other parts where the language interacts. So for instance, if we have a regular function base, we can just call it base, and we'll be implicitly calling it. But then with templates, even though they basically have the same model of you're just calling it, getting the value, you still have to, even if it doesn't have any arguments, you still have to put the what's it called, that bang and the parentheses. So this is completely arbitrary. I'm sure there's a good reason for the way like the parse and things work currently, but fundamental, these kinds of decisions are arbitrary, and all of this complexity tends to accumulate, and it trips up beginners and interacts in bad ways. Then there's, in terms still of thinking about what compile time means, there's CTFE. Who here knows what CTFE means? What does it mean? Come on, it's easy.
Well, execute an expression at compile time by compiling its pieces if they are missing.
Yeah, and what does the acronym mean?
Compile time function execution.
Everybody agrees with that?
Yeah.
I don't know. Half of the times it says compile time function evaluation. And I've seen lots of people argument it should be evaluation because it's just a generalization of a constant folding and so on. And while the official spec says this compile time function execution, but you'll see all of these different nomenclature everywhere. So you can't even agree on what some of the most basilar fundamental building blocks of modern D are called. I agree with you, it should be called compile time execution. I don't think we even have to focus on the function, because in some contexts you don't have to involve functions. There's also the issue of what should be CTF-feable, what should be executable at compile time. And I don't think currently there's really a good specification level rule for that, something that very clearly defines that. But it should be something where if I ask you, there should be like, oh, it's total, there's that rule, and I know if I apply that rule, I'll be able to answer that. I don't think that exists at the moment. So that's another area for improvement. So once we have all of these different differences, they tend to compound. So one thing that I really like about the more modern versions of the modern, talking about like last quite a few years, compare like D1 and early versions, is we have this unified function calling syntax where we can replace these very inconvenient chains of function and algorithms executions with this flow that much more clearly represents how the data is being transformed step by step. So you transform from the top there syntax to the bottom one. But then, of course, this doesn't really work with templates. Attila has this interesting article about what he got wrong. He has some examples there about some ways where you would want to use this with templates, but UFC doesn't really work there. You can look at the article to look at it into more detail, but basically this is kind of like what you have to write, And this is what you would like to write instead using the UFC syntax. And in this example, you still have to factor out these functions that you're calling at compile time. But actually, I argue that we should also, for instance, be able to use lambdas with templates. And so this is just another example of all of these arbitrary differences, because some things work with regular code, some things don't work with templates. We have these two separate universes inside of D. Another example would be function arguments, where you want to pass a function to another function, like first-order functions, first-class functions. And if you are passing a function at runtime, you have to use the ampersand syntax, while if you are passing it to a template, you don't have to use it. And then, of course, these will compound with things like if then you specify, it'd be great to have a property-like behavior where you don't actually need to put the parentheses to call it. Then suddenly this works with one of the syntaxes, doesn't work with the other, and so on. I believe that one of the strengths of D is its plasticity. It depends a bit on how you use it. But for instance, here in this example, I have defined a struct foo, and I'm accessing a member of foo, x. So I write f.x. But then suddenly it's I don't really want the value of x. I want something a bit different. So I want to create this kind of indirection layer, but maybe I just want to prototype some idea really quickly. So I don't want to be having to change f.x everywhere. And this is the kind of changes that are really easy to do with D, because you just hide the original x, and you introduce these member x methods, and you still just call it f.x, and now it calls the function instead of directly accessing the member. And so it's super plastic D. And this is really convenient, being able to do these changes. You can quickly prototype a lot of changes without a lot of trouble. But then, of course, it's just one of those examples where this doesn't really work with templates. Let me see the slides here. So, I think I got a problem here with my slides. Anyway, here in this example, I'm passing two runtime variables to a function, and suddenly I decide I want to change one of those variables. So instead of being a runtime value, just being a compile time value, so I changed the y from being an int to being an enum, and suddenly on my call side to the foo function, where I used to just call it x colon y, now I have to pass it with the compile time arguments and the runtime arguments, at least if I want to preserve the compile timeness of the member y. In some cases, you do want to do that. So unlike the previous example where we were able to do this transformation without really affecting the rest of the code base, here, if I wanted to preserve this compile timeness, we have to change the call sites. And this is an issue that does arrive in practice as being problematic. And I found it interesting that this was one case where maybe not C the language, but at least GCC was actually better than D. In GCC, you have this magic called built-in constant P. So for instance, here I have this function, this C function bar, it takes a runtime argument, X, but I can, even though it's not declared as like a compile time variable, I can actually ask the compile, do you really know what the value of this X is going to be? And based on that, I can actually make some different decisions. And this is just a nonsensical example that I came up. So it's like, it's not supposed to make a lot of sense. Example, so like, what's the point of this? How would this be useful in any way? The example where I found this in the real world is for an SDK of a chip where you wanted to write some control register of that chip, and you just wanted to write in your code, write to that control register, that specific register, this value. And this was a preprocessor macro where it asks, well, if I know the value at compile time, then I can use the good encoding of the CSR instruction, where I encode the immediate inside the instruction itself. And if I don't know it, then I'll just have to pass it on a register. So you are able to optimize your code based on asking the compiler, do I actually know at compile time what this value is going to be, even though I'm using a syntax which it looks like this is just a regular runtime argument. And that's kind of the point. It's like, for users, this just looks like a regular function, so they don't have to think about all of this magic. But it's also that it interacts well with your environment, because if suddenly that 7 was coming from some other header, and it turns out it's no longer something that's defined at compile time, you don't have to change the function between, write DCSR with some value I know at compile time, or write DCSR with some value that I don't know at compile time. So you automatically get the best behavior based on what parameter you're actually passing it to. You could also see these with examples like formatting functions, things like that. So here I have my formats. You pass it a format string and the value that you're going to put it on your format string. So the case where you don't know anything about those arguments, you just call it normally, right? But then there could be other cases where you know the format string, but the argument of how you're going to put the integer value there is going to come at runtime. And there's also the case where you know both of them at compile time. And you want to have like this uniform syntax for those, but then take advantage of the knowledge there and optimize based on that. And that's something that was introduced not that long ago in Phobos, the standard library, with the right formatted write FLN function, where now you have the possibility of passing the format string at compile time. But then this was an intrusive change. You have to actually go to your code base, change all of your format strings to be passed as compile time argument. So you don't have the benefit of just, even though the knowledge is already there for the compiler, you can just say, please do take advantage of the knowledge. So you have to change all of the call sites. And it's not very obvious how, in general, if you are using this in generic code, how you don't take advantage of this without creating a big mess. And notice that even now, even though you're taking advantage of knowing the format string at compile time, you're not taking advantage of knowing the other arguments at compile time. So you can't like actually know, I know the format string and the arguments. Let me just pre-compute the old string at compile time, and then I don't have to actually do any work at runtime. So it just kind of proves that you really have to, as it currently is do a lot of work to take advantage of these properties, and this is like not the best possible model. Let's skip these. Okay, so let's talk about what I think could be an alternative approach. But before that, let me just ask you. So one way to look at it is like saying, that's just how D works. You're talking nonsense. You're talking like properties of templates, and that doesn't even make any sense. So just don't do anything. Another way, it's like, okay, I could see that there are some inconsistencies here and there. Maybe those could be improved. And you go over each one of them. You try to make them a little bit more consistent, work better with each other. But that's going to be a lot of work. And it's very easy for different differences to leak out and become visible. And you have to maintain all of this parallel infrastructure. Another possible idea would be to really build some kind of common building block, some kind of infrastructure where you can then build the more advanced features on top of. So that would be solution 2 and kind of what I'm talking about here. So what's the type of these? Int, yeah. Pretty simple. What's the DMD output for this? Compiler error, yeah. It's like, you can't modify constant expression X. So you have a type that says, well, this is an int, but you can't modify it. As easy as it goes. So what's the type of this? Int. What's the DMD output of this?
I cannot assign to alpha u or something.
cannot assign to our value something like, oh, it doesn't really matter. It's cannot modify constant x. The other one is cannot modify constant expression x. This is one cannot modify constant x. I don't know why one focus on the expression, why one focus on the variable. Seems arbitrary difference. I would say the enum one is the one who should focus on expression. But on the enum, the type of the variable is int. So one way of looking at it is like, well, you're giving me the properties of this variable, what it should do, what you can do with it, what you can't do with it. But the int doesn't encode the constants that you can't modify it. And also, it doesn't encode the compile timeness. So there's this mismatch where the type system isn't really working for us. We have to keep this parallel notion of what we can do with types, while in many places it would be much more convenient to just have those notions encoded as part of the type. So how do we add to that enum x that we want to have at the level of the type system some notion of compileness? Compile timeness. Well, we could add some kind of compile time qualifier to the type to say this isn't just an int, this is a compile time int. So what kind of qualifier? What do you think of this proposal? Compile time int x. Is that like a great syntax or not? No, come on, this is a great syntax. I'm sure Walter would love this. What about comp time int? I don't know why you're complaining that much, because this fits pretty well with Indeed. It's like C++ has like the ampersand. We have ref. It's like it's more verbose, more explicit. We have immutable. Why don't you like comp time or compile time? It's like immutable. It's like a really long keywords. So I actually think this is pretty reasonable. But if you don't like it, I guess we could go for something a bit shorter, like for instance, like some kind of pound or something like that. It's like compile time int. So now you're going to read this every time you see like the pound, you're going to read it as compile time. So what's the type of x? It's a compile time int. So how do you declare that enum variable? Well, it's not really a compile time int, because a compile time int would be something that would be modified. So then you need to also include in the type some notion of constants, right? So probably either a compile time constant int or a compile time immutable int, something like that. Immutable, as the advantage, is kind of long keyword. But I think it's the one that generalizes better from the notion of int.
We could reuse the static keyword.
Yeah, it's really an overloaded keyword. Static int. Wow. Okay. So now we can have things that you used to not be able to have, like you can now have model level ints that are mutable. So for instance, you could declare a container where I'm going to gather the names of all the things I use, and then you get, for instance, compile time reference to something, which is like an alias, and you get the properties of that, and you mutate it. So you have all of these different approaches where we just broke these completely different worlds that you used to have between the EST and the compile time function execution. In terms of compile time statements, how could this work? Well, you could prefix them with the pound to make them be executed at compile time. So for instance, a static if would be a pound if condition. And I'm not sure here, perhaps also dynamically based on the time of the condition, if it's declared as a compile time condition or runtime, it would have different behavior. Then you need to worry about the scopes introduced by the braces. So currently, this is very contextual. If you have a static int, the braces don't really include a new scope. There are several different approaches that you could handle that. I'm going to skip over that. What about function templates? Well, used to have all of these separate compile time parameters and the runtime parameters. You could integrate them. So it's like now we'd really have an uniform function calling syntax. And one of the advantages of that you can change their types and you don't have to shuffle around. So for instance, if B transitions to a compile time B, you don't have to shuffle their order around. And now we are ready to answer what's the type of a template. It's not template, it's not void. It's as some of you were saying, it's a kind of compile time function, right? Something you do at compile time where you can generate this code, return these values. And so the exact type would depend on what arguments it receives and what it returns. So for instance, it could be a compile time function that receives a compile time int and returns a compile time int. Then you have to answer how would this approach be able to do things like declare struts. So the hard way to do it in the old way be where you have a template. I think the equivalent way here is that you have a compile time function that receives a compile time integer argument, and then you return the type itself. So you need to have first class types. A question here?
Well, this one doesn't work either. Oh, here we go. We've got volume.
Okay, now it works. That is something the parameterizing compile time type does not work, because then the is breaks. So the reason we have the hash tables for templates is because there are actually fundamental principles in the type system that do rely on the same template being instantiated with the same parameters, resulting in the same type, and we cannot break that. That the one that you have there right now cannot work that way. You would have to wrap it in a template.
Yeah, I get what you're saying. I think that there are a lot of challenges with this, so that's why this is very exploratory. And I'm aware of that issue of things being able to return different, with the same arguments, return different things. So that's like, if you have a non-pure compile time function, that could impact type equality. It's basically what we're saying, right? So that's an issue. I'm completely aware of that, but I think there are solutions for that. Let me just speed up a little bit to not take too much of the time. What about other compile time types? So first class types have types themselves. So where you'd have a compile time type here, I guess the equivalent would be that you receive some T, which is itself of type, except that type is a compile time type. And that's here, perhaps in some cases you'd want to integrate the notion of type off and runtime type information. That has some pros and cons. Another issue is that how this would work in terms of type deduction, where you pass in the template parameters the T, and then you deduce it based on the calling site. There are several possibilities for how this could work. For instance, in Sparrow, it has the any type, so this is kind of a wildcard. In Jai, it has the dollar syntax, where you mark from which parameters you want to deduce it. There are different approaches, like for instance, you could receive optional arguments that you don't have to explicitly pass, and those could interact with the other ones. But depending on how you want to do that, then we might have to relax the rules for passing optional arguments in different parts of the calling order. Another issue, of course, that if you start putting compile time this and that, suddenly you have like compile time everywhere. So you're putting these hashes everywhere. That gets old really, really fast. An issue where if you just want to do like CTFE type computation, you could just mark a function as being compile time, and you wouldn't have to like declare every argument and every variable and every statement as being compile time. And that would just get lowered by applying the compile time notion to each one of those. And I think this part here also helps to answer what makes something compile time executable, where first you want to get a function that was just a regular function, you applied the compile time modifier to it, you recursively apply the compile timeness to every part of it, like every statement, and then do type checking on that and see if that is able to be compiled and run. And for calling runtime functions, doing that lowering, you'd use the pound syntax. I'm going to skip a little bit more. So one advantage of this approach is that you could get a lot of features that are currently separate features and just use these compile time functions to do the same thing. So why do we need to have a pragma message? You could just have some kind of function that at compile time outputs a value. When we read files with this special import statement, we could just have a compile time function to read files from the file system with security concerns, of course. I don't think we really need to have all of these great syntax, not all of them, when you could just have a much more clear compile time API, where it just be just another API, except that the functions are compile time functions. And I see a lot of uses of string mix-ins, where you create all of these arbitrary coded compile time, that a lot of them I think could be a lot more clear if you just had a much more contained API which did much more specific things. You wouldn't have too much flexibility. So here in this example, instead of manually doing the parent dot the member, you could just call the compile time function get member from a reference to the parent with the name of the member name, and it would do the same thing as that string mix-in. I'm not sure where, I don't think there's any language that explores quite this region of the design space. So for instance, I borrowed some of the ideas from other languages, and you can see that they try to address similar things, but they don't really go there to the same territory. So yeah, I know this was very speculative. I'm totally sure almost none of you were convinced by it, but I feel there's like this core of a potential there. So I think this could be further worked upon, massaged, and maybe even if it were not applied directly to D as it currently exists, some good ideas could be ported back. So I'm still playing with these, and if you have, like I saw before, some good ideas that you can share with me, try to see if we can make some progress of these. Your feedback would be totally welcome. So thank you.
All right, and it's question time now.
One thing I didn't see you mention that hits me a lot of the time is underscore CTFE. Because sometimes I write a function, especially for mixins, that is only ever called at compile time, and then the compiler complains if I'm using a runtime parameter at compile time, saying, I can't read this at compile time. Yes, you can. I'm only calling it from CTFE. So yeah, I don't know what you think about that.
It's interesting. I'm not sure I actually did think about that, but that does sound like something that you really want to have like a test case for that to see if the design solves that. So I couldn't list it all, but I had this huge list of different, and I want to make sure it works in this case. I want to make sure it works on that case. But it was such a laundry list of little issues that I couldn't really put them in the presentation. But I have a long list of that kinds of issues. So if you can share your concerns with me, maybe I could make the list better cover of the concerns. And yeah, so that's a like very, very valid point.
Yeah, I think we in particular have a lot of the same work that we did. For example, I wanted to do the same thing you did, but except I didn't use the hash. I did use I repurposed the alias keyword, because that already expresses that something is a type or that something is only known at compile time. And we should definitely talk about this together. Thank you very much for bringing more attention to this. I'm very happy with this talk.
Yeah, thanks.
All right, are there any other questions here? Manu?
I'd just like to share an anecdote that I had. I recently did a hackathon in the office where one of my colleagues was exposed to D for the very first time. Going into D, he was very happy with it. he did a whole bunch of meta and complained bitterly for days about all of the things that you discussed in the start of his talk. And then his takeaway from D was, yeah, I kind of like D, except I wish it was pretty much the way that you've described.
Wow, but that's like the best compliment I could get on that. Yeah, that's wow. Thank you for sharing that anecdote.
All right, any more questions or anecdotes? No, looks like we're done. Thank you again, Luis.
Thank you.
All right, you know what happens when the big hand meets the little hand up there? It's 12 o'clock and it's lunchtime. So back here in an hour and a half for our keynotes talk.
I think that the idea is a great idea, but I think we could fit it into the current language.
That would be great.
Why not 0 p.m.? You know, that would make a lot more sense.
My talk was on this.
It was surprisingly good. Yes, I don't know how you people managed it. Really, I don't. All right, yeah, okay. So, thank you for saving the day and knowing what Mars is.
Now that we've sank too late, shouldn't he offer drinks to everyone?
I think it goes the other way around where you meant to buy the birthday boy drinks, but you know. Who's next? Who did we put next? We put. Oh, we did put Adela next. Okay.
If I need like a couple of minutes just for a quick smoke, I'll be like.
Yeah, sure. I
Yeah,
mean, we're setting
minutes.
up now anyway, so off you go. Where'd Lace go? I need his wire. Can I get your wire? Thank you.
Sorry, yes.
Yep, by all means. Cheers. All right, you're probably the only person here I don't need to tell how to set up this stuff. So,
Probably not.
you got the HDMI in good. This monitor should be on as well. I don't know why it's off. But the dude was just heading out for a ciggy. He'll be back. But yeah, those two screens replicate what's up there.
Okay.
Standard HDMI, so you can duplicate or extend your displays, whatever. You don't need that explained.
This is the slowest post ever. Why are you still staring? This can't be right. Come on, beer.
Wow, I've never seen that line on it before. What was that?
That was the boot.
Or was that Grub or something?
That was system deboot
Oh, okay.
with lots of entries because I'm trying to figure out.
She said it was scanning and repairing a drive there.
It does that all the time. I don't know what's going on. Picture of me from 100 billion years ago.
Yeah. Actually, one other thing that I'm trying to do with everyone is make sure I pronounce their names correctly, and I'm pretty sure it's just Attila Nevis. Okay, good. I was certain I'd been mangling your name for years, but
No, so the thing is that I pronounce my name in English when I'm speaking English.
okay, fair enough. Attila Nevis, got it. Yeah. Other than that, we're starting in about 4 minutes.
I don't have an actual viewer. Shit. Yeah.
I should. Dobreeder has a full screen viewer.
What does Chrome?
Well, Chrome should be able to do that as well, right?
But with pages?
Okay. Yeah, you might need to go into a viewer program then. Fair enough.
Gonna have to install them.
All right. Well, you got 4 minutes.
So how do things work with the lightning talks? Do you need to submit it somewhere?
Best to talk to Mike about that right now, please. Thank you.
So he was a maniac for eliminating weight on
Screen's coming through in the feed fine?
Yeah,
Excellent.
Download.
Yeah, he's downloading an actual viewer so that he can get a full screen of his slide. It's in PDF format, but he's only got Google Chrome there for reading PDFs, so he's got to fix it up properly. All right, man, just let me know when you're set up and I'll yell out. People have a minute.
I want presentation about. I won't have a thingy magic, will I either? So I have to keep it on the back of
If you need a clicker, you got that. USB here. It should, if PDF, should be able to read the forward and back on that.
Okay.
And when I was trying it out, the weird thing was that down goes forward, so whatever. It's a bit unco, but it works. Yeah, the feed's coming through. It's fine. I just checked with him.
Oh, okay. So I don't need to do anything.
You don't need to do anything now. When you're ready to go, you switch the screen. All right, I'll yell out. All right, we're live in 1 minute, people. Please come back inside. Okay, welcome back, everybody. Everybody? Everybody. Yeah, I'm with it. I'm with it. I'm cool. All right, please, you take your seats over there. All right, good enough. Good to go. Oh, we were going to play that little D game, weren't we? Hold on. Let me bring up my little trivia.
You got the prize?
Yes, and Mike's a prize for me over here. Thank you, Mike. All right, let's find a good question that people can answer. All right, here's a bit of trivia that Walter provided me. What was the model for D's nested functions? Where did he get it from? Nicholas put his hand up first. Yes, correct. So he said Pascal for those who can't hear.
Woohoo! And you didn't see it, but I put my hand up as well.
Yeah, you should be in the crowd. Hey. All right, so what do we got here? We got a Dr. Strangelove reference in the title. I like that. Subsequently, there's a Kubrick exhibition over at the Design Museum at the moment. I looked at it on Tuesday. It's pretty good. Completely unrelated. Attila Neves is going to talk to us about frictionless D adoption. So give him a round of applause.
Thank you. So basically, the C processor sucks, but it's also awesome. And, well, we'll get to it, I guess. All right. If you remember just one thing from this talk is that programming is about people. I know that we want it to be about the tech, but it's not. Trust me, I want it to be about the tech too, but it isn't. It's always about the meat bags. If you're not thinking about the meat bags, you're going to fail. So if you take one thing from this talk, that would be it. I'm done. No? Okay. Story time. So John Montague was the 4th Earl of Sandwich, and apparently, according to legend, he liked to play cards. He also enjoyed having a little snack while he was playing those cards. And he wanted to keep one hand free for the cards, went out for the snacks. So he asked his valet to bring him some meat in between 2 pieces of bread, and voila, sandwich. The other guys that were there said, I want what sandwich had. The name caught on, and this is why there's a picture of delicious BLT up there. Why did I talk about that? Because it's a story, okay? So humans, for reasons, respond really well to stories, and people sensitive to storytelling. Research has shown that if you use a story to relay facts, people learn a lot faster, and the retention of the facts is a lot higher. In fact, if you put electrodes in somebody's brain, that's an actual picture, the brain fires up. It's not just one region of the brain that fires up. If you show them bullet points, you get one region of the brain firing up. If you tell them a story, the whole brain lights up, and things are better that way. So you're now unlikely to forget the story about how the sandwich was named, whether or not that story is even true, because there's no way to know. But you're not going to forget it. On the other hand, nobody's going to be talking about the slide at all because it's boring. Boo. So that's why I told you a story, because stories are important, because they're important to people. And like I said, programming is about people. So if we don't account for the people we're working with, we're not going to be successful. So the whole point here, I think, is that I think everybody in this room wants the adoption to grow. And if we keep forgetting this fundamental fact, we're not going to succeed in achieving that goal. So again, programming is all about the meat bags. Drats. Right, so to contextualize the story, this is your basically who I am slide. If you don't get why it says why instead of who and who that blue guy is, then you haven't watched Avengers Infinity War, and all I can say is I feel for you. It's amazing, go watch it. So I've been a D user since 2013. Actually, this conference was a big part of that. I was watching the videos online, thought it was really interesting, downloaded the compiler, started trying the language myself, and very quickly also read the T programming language in one sunny afternoon from cover to cover. Very quickly, it displayed C++ as my language of choice, my favorite language. So I started getting really into the D community and ecosystem and all that. The next year, I ended up DConf 2014 at the Facebook headquarters as a speaker, started meeting members of the community, really started, getting to the swing of things. So I wanted to use D round about that time. Unfortunately for me, that was also the year in which my previous project at work had ended because we had achieved everything we set out to do. And so they had to move people to a new project. So they put me with a bunch of programmers I'd never worked with before. They were all C programmers, and we were about to take ownership of a code base that was written by a completely different team in a different continent. And they just handed it over to us, and now it was ours, which is every programmer's dream, right? Living the dream, taking ownership for somebody else's crappy code in C. So that was great. And the thing is, there were no tests, right? I mean, the previous team didn't write any. Well, they wrote a few, but there were hardly any. They didn't even compile anymore because they hadn't been running so long. And I told the team at the time, remember, they didn't really know me. We can't change the code until we cover it with tests, because or else we'll break it. I mean, who knows what we're doing there. I really recommend this book, which is instrumental in some of the techniques I ended up using to test the code we had, because it wasn't made for testing. They didn't have the tests in. The culture at the time when I was working at Cisco was really to do end-to-end tests on actual hardware. And the hardware obviously isn't a PC, so that makes things more complicated. They usually actually serial lines to talk to the boxes and type commands in, that kind of thing. That was the environment I was in. So reading this book's really good. I recommend it if you have to work with legacy code. It's mostly focused on OOP techniques, but it doesn't, so Java, C++, but it does mention some C code techniques you can use as well. I didn't manage to get anybody else in the team to read this, but what are you going to do? The code base is in C. That doesn't mean I have to write tests in C. In fact, I don't think that's ever a good idea. I mean, there are reasons to pick C, although not that many, I would say. Basically, if you have a compiler for anything else, use that instead. However, you don't need to write tests in C. I mean, you're just making life hard for yourself for no reason at all. And so I had to decide what language to use. Now, I wanted to use D, but I ended up using C++ because it was easier. Did I like that choice? I did not, but I had to make it anyway. Now, why? Well, first of all, again, new team. And They didn't even do tests. This is a culture when they did manual tests and thought that was a good thing. When we talked to them about automation, they thought that was a bad thing. I don't know why, to this day. But it was. So there's a culture problem already. So I'm already fighting to even get the tests in to begin with. I counted the number of meetings we had to discuss unit tests. It was 8. I counted them because it was so frustrating having the same conversation over and over again and trying to convince people that unit testing was a good idea. At one point, somebody said, but you want us to do more work? And I went, no, I want to do less work. I'm a programmer, I'm lazy. That's definitely not what I want. I want to not break the code and not be debugging for days in a row. So if you're arguing, you're losing when it comes to persuasion. So don't argue. And basically, I was already arguing about tests. So this is already a situation that's hard enough to begin with, okay? I'm already trying to convince them. They don't know me. They've never worked with me. They don't trust my judgment or anything like that. Or I'm having to prove myself. So in a way, my career is on the line. So I have to try to make choices for this team that would make sense. And again, if you're arguing, you're losing. So also change, right? People hate change, it turns out. They really, really do not enjoy it. Well, most people. There are weirdos. But for most people, change isn't good. And if you're wondering if the slide title is supposed to be sung to a song, it is. Most people have this naive model of change, in which these diagrams are from Peopleware, by the way, which is also a great book that I recommend. In fact, anybody managing a software team should have to read this book before going forward. It's basically where I learned that it's all about the people. In any case, most people think you have an old status quo, and then a better idea comes along, and everybody is enlightened immediately and goes, hello, new status quo. Nope, that's not what happens at all. What happens is usually there's a foreign element, in this case, me, in that team, introducing an idea, then chaos, and then there's a bit of time so that they can get used to that, and then they practice, and then they get better at it, and then the new status quo happen. If you want to know more about it, like I said, just consult the book. And the change doesn't really happen until people feel safe. If they don't feel safe, they go straight back from chaos back to the old status quo. So you need to take this into account as well as the evangelists out there. Maybe the best way isn't to jump straight in. Maybe something like Better C is a way to get them in the language. It has to be piecemeal. It has to be easy. They have to feel comfortable. If they don't, it's not going to work. People don't like change, and I was introducing change as it was. There's also this phenomenon known from psychology called loss aversion. For probably evolutionary reasons, people prefer, we're really averse to losing anything. And apparently, some research shows and indicates that loss is about twice as powerful as gain. So it only evens out to people when it's about twice as much. So loss bad, gain good. Some of the psychology experiments, basically, if you give somebody money and then take it away, they feel that much more strongly than missing out on getting the money to begin with. So we don't want to trigger that aversion. We don't want them to feel like they're losing something by going down your path of change, whatever it may be. In my case, again, trying to cover this code base with tests. And automated testing was chaotic enough for them. Getting them to adopt D, that's a lot harder. So, I had to be able to sell that. But you can tell me, you can write the test in D, right? What's the problem? It's called the C code, no big deal. Sure, okay. So if you go to dlang.org right now, and I can't remember exactly what it's called, but C interrupt, whatever it is, that's the example they have, shrinker. First of all, nobody's going to do this because it's already done for you in standard library. The declaration is already there. Secondly, if those are your problems, good for you. But normally, you're not trying to call a function that takes 2 const shards and returns an int. It's usually much, much more involved than that. In reality, it probably looks like this function I called weird API here, in which you have pointers to structs instead, and then some integer, and I called it weird API because naming is hard. Now, the thing about this is that foo will be in foo.h, bar will be in bar.h. And then if you go look at those structs, they have substructs within them that are in different headers, which if you go look into those, other structs, other headers, and this goes on and on and on. And the code base I was trying to cover with tests, that would recurse about 20 times. Completely different headers. So that's what the real code that people are trying to call looks like. It's a lot harder than that. And there's another problem as well, because you see int flags there. What'd you pass to it? 42, 33? Nope.
you need the preprocessor, because that's how the API is designed to be used. Okay, so what you can do here, of course, is try to emulate the preprocessor using CTFE, for instance. That can work, but it's also manual. You need to figure out, and sometimes it won't quite work because the semantics is slightly different. Maybe, here be dragons, and also, so the way API is meant to be called is like this, with the preprocessor actually using the flags there. You're not assembling it manually. As you can see, weird API returns int, but in the call, nobody's checking for the error code because it's a C API. Let's face it, every return value is an error code, and normal programmers don't usually check. And so, what do we say to the god of error checking? Not today. Anyway, so that's what real APIs look like, and that's a problem. And then you get things like this. If you have nested structs, sometimes people write macros like this one to facilitate getting a member of a struct, because obviously writing code is more important than reading it, even though you do the latter a lot more. You can tell me who would do such a thing? Psychopaths that write code that I didn't have to manage. That's who. But they do this. And it turns out that this shows up in the code all over the place. I kept trying to jump definition. That function didn't exist because it was a macro. Can these things show up in APIs? They can. It's probably rare, but these are actual problems. And these are problems that I had in that code base. These aren't even theoretical problems. These are things that actually happened. So this complicates matters a lot. So what we can do, I could manually write all the declarations and recurse myself into headers and look at them and then do this and do that and look at if defs, because that's the thing. The struct declarations can use a preprocessor too. Which version do you use? How are you going to compile this? Are you going to do version blocks in D? You're going to do static ifs? You can, but that is a lot of work. I reckon that it would be weeks and months of manual wrapping just before we managed to write the tests. Okay? I tried D-step. It didn't work. I don't remember what happened. I just remember it didn't work. And I at one point was trying warped, the preprocessor that Walter wrote, because I was trying to see if I could at least just run the preprocessor first and somehow get the declarations from out of that so I wouldn't have to recurse into the headers. Warp didn't work on it either. Sorry, Walter, no, I don't have a bug report because I can't remember what happened and I don't have access to the code anymore. And Calypso's a non-starter. I mean, yes, there's Calypso, but it's a fork of LDC that does this weird thing in which you can use C++ and D together. But, again, they don't even know D, okay? If I'm going to convince them to use a different language, and they go on the internet and look up how to use DMD, and I tell them, actually, no, it's this other thing. It's a fork of another compiler. That doesn't look good, okay? The loss of version thing will trigger immediately. They'll just go like, nope, don't want to. It's a non-starter. It's not a viable option. And so because of all of that, I picked C++. Because, back. That is the elephant in the room, okay? And C++, this is all the work you need to do. The externcy might not even be needed if somebody wrote the header properly, but in this case they didn't, so it was. But that's all you need to do. There is no conversation happening anymore. You do this, it's done. All of the structs are now usable. All of the API and all of the preprocessor macros. And they work exactly the same way. There is no loss. It is as smooth as can be, okay? No argument here. So I did that. Also, I mean, these are C programmers. They didn't even know C++, okay? So that is also a bit convincing, but they could pretend to write C, sprinkle in some niceties maybe, like using std vector for the test, and really not have to be any the wiser. They can just write the code they already know, and it will work, and it'll compile, and it will link, and it'll do what they think. So this annoyed me because I wanted to use D, but I couldn't, okay? For me, this was the advantage that C++ had, and I wanted this for D. I wanted it for somebody like me who wanted to use D to not have a reason not to. And that's the advantage C++ has. I think its rise to power, from a historic perspective, has everything to do with that. I don't think we'd be here right now if C++ hadn't done what it did, because Walter wouldn't have implemented the C++ compiler and wouldn't have invented D. And the only reason anybody's still talking about C++ is because it made the transition completely and utterly zero cost. Oh, you have a C code base? No problem. Just create a new file with the CPP extension. Everything will work. You can use your old APIs. nothing changes. In practice, it's a superset of C. Yes, I know it's not, and I've run into edge cases where it's not, but in practice it is. We could just pretend it is, and it's a first approximation. That's basically the case. Incremental adoption, no cost. There literally is no cost adoption. If there's no loss aversion. You can't be averse to something that doesn't even exist. You can't lose by arguing if you're not even arguing in the first place. If you're arguing you're losing, no argument. And I believe to this day that C++'s killer feature is hash include. It's one thing that differentiates it from anything else. It's the one thing that caused me to pick C++ for this project instead of D, because there is no work involved. So my conclusion, of course, is to shamelessly copy what C++ did. That's how it rose to world domination. That's how it conquered so many people and swallowed up whole projects. I mean, even GCC is in C++ these days. So let's do that. So what do we want it to look like? This is a hybrid Frankenstein monster of my creation. If you don't look carefully, it just looks like I wrote C code, but I didn't, right? Because you can see a scope exit there and a const without an auto, so it's not even C++ either. So that's D code, except it's not, because there's hash includes, which isn't valid D. So I want this to happen. I want to be able to write this code, and I want it to compile, link, and run and do what it's supposed to. Incidentally, those AF, SP, and NNPub values there are macros, because that's how you're supposed to use the API. It always happens in any non-trivial C API. You always need the preprocessor somehow. It might just be constants, but it might be something more involved. So this is what we want to do. I want to replicate the C++ experience of interfacing to C. I want it to be as painless as it is when you write C++ and are interfacing to C. I want everything to just work and not have to think about it. The other thing about this as well is that I don't want to see any D declarations from the headers either, because why would you? That's for the compiler to know. And if you want to know what the functions you're calling, go read the header. I mean, C code isn't that much different anyway. So just go to the origin of the code you're calling, go look at the declaration, and that's fine. So how do we make this work? Well, like D-step, DPP uses libclang. I call it DPP kind of for marketing reasons, I hope. I read it either as D preprocessor or D++, take a pick. So we use libclang, which is a C API on top of the Clang front end. And that way we can call into Clang's parsing engine via D, so we're using the C API. Then we take the AC that we get from the headers and we translate those into D syntax. We do have to deal with some impedance mismatches here though, because for instance, C, you can have multiple declarations, you can have as many as you want, as long as there's only one definition, but not in D. So we need to fix that. But the thing is that when you're including a header, you don't get things in the nice order, as it were. So you need to go find out which one of those you want to actually use. For instance, for a struct, you can do struct foo, semicolon, several times, and then have a definition somewhere else. So we need to find that one. Now, libclang does have a concept of what's canonical. You would expect, naively, that they would pick the definition as the canonical one, but they don't. So I have to do some filtering basically after it's being parsed to actually get the information I need, because I can't repeat myself because the decompiler won't let me. There are other little issues as well. And then the idea is to take those headers, expand the translations in place, just as they are there. Basically what the preprocessor does in C and C++. And I originally did this per header file. That didn't work once I found a bug, because there's a big C project, I think it was Postgres even, in which you're required to include a certain header before you can include any of their other headers. So their headers aren't self-sufficient. If you don't put the declarations here, the other ones don't work. So I can't do that anymore. So what I do is I take all of the headers, all of the includes I see in a DPP file, copy them somewhere else in the file system, and then parse that alone by itself as C or C++. The translations are meant to be checked in, which means after you convert C codes to D, I don't actually want to look at the file. To me, this is just part of the build system. Okay, you generate some D code as part of doing your job, but you don't actually look at it. That's not what you're working with. So they're not. It's a different philosophy from DCEP in the sense that instead of translating and then importing that module, you don't. Right? You don't look at it. You just, again, replicating the experience I want it to work just as easy as. And the other big difference, of course, is macros. What do we do with those? Now, by the time you've used libclang, it's a compiler, okay? The first step in compiling C or C++ is a preprocessor, but by the time you've parsed, the preprocessor is gone. It doesn't exist anymore. All of the macro declarations are gone. However, probably because somebody else is doing something similar to what I'm doing here, libclang is an option when you parse a source file that it remembers where the macros were, even though they're gone. So you can query it for the macros that were in those headers. And then what I do is redeclare those macros in place. So if I have defined foo something, I go find out where foo was, go open that file, read it from this position to that position, which is where the definition is, and paste it in line. Exact same definition. Because instead of fighting the preprocessor, I figured just use it. I could use warp to something like that, but instead just call the C preprocessor. So the idea is expand all the declarations in line, take all the macros and paste them in here, and then run the C preprocessor in the result. That means your code, the user code, the code that the user sees after the includes, can then use any macros that were defined in those headers. And then the C preprocessor takes over, expands those for you, and everything just works the same way it would have done otherwise. Is it hacky? Yes, but that's how we do it. If you can't beat them, join. And then, of course, at the end of this process, you have actual valid decode, right? Because this here isn't. This isn't valid D yet, but it becomes valid D after this process of expanding it in line. So what the compiler will see afterwards is those includes are gone, and then you have a bunch of definitions there. Yes, Walter.
Hello? So you're running the preprocessor also on the decode?
Yep.
But then you've got to, it expands to C code.
We'll get to that.
Okay.
So the good thing about this is, and then we call it decompiler the resulting code. The good thing about this is I'm wrapping the compiler, right? It's a layer on top of it. It's not replacing the compiler. It's not a fork. Those things are scary. This is, chocolate bunnies and flowers, because there's nothing to be scared about. The compiler is just doing its thing. I'm just pre-processing beforehand. Again, I'm shamelessly copying for C++. The first implementation was it pre-processed what became C++ into C and then compiled that. Yeah, let's just do the thing. So that's how it works. But yes, there's problems with that. I'm not entirely sure how to fix it either. So how do I call libclang from D? Fortunately for me, Jacob wrote D step and already had the bindings. So there's libclang declarations in D syntax. Because obviously I have a chicken and egg problem here. I can't use this project to, translate. What I did do though is I added safe no GC pure no throw to every single one of those declarations. Now, is it safe? Yeah, probably. I trust those guys. Is it pure? Look, if a pure tree falls and D doesn't see it, it's pure. It's fine. I don't. It's obviously no throw because it's C API anyway. And I also added into all of the parameters. The reason I did all of this is because I hate writing code that's not safe, that's not pure, and that doesn't use const. Okay, that deeply disturbs me. So I did this. I basically trust the libclang implementation, and I do make one exception for callbacks because the way they do it is basically they kind of implement the visitor pattern in the sense that you give them a function that they run on the ASC nodes. And I can't guarantee that that function is going to be safe or pure or whatever. And also I can't limit what users can do calling libclang, so I don't do it there, which is the only place I can't. But the good thing is I can write safe code, pure, and also use const values everywhere and things work. I mean, I haven't corrupted memory yet that I know of, so it probably works. And then I wrote OOP-like wrapper for the C functions, right? Because they're annoying to use, so you just declare a struct, some member functions called the C API. There's a few other things that I did as well. I put all the enums into their own namespace, so they're easier to use. Sometimes they don't look exactly the same as what's in the header, so I have to go back and forth, but I still think it's a lot nicer to use it that way. So that's how we call libclang first, and then we just tell it to parse because that's what it does. So in the implementation, what we do is, so libclang in its parlance, the AST isn't made of nodes, they're called cursors. and cursors can have types or not, depending on what kind of cursor. For instance, a namespace cursor doesn't have a type. That doesn't make any sense. But a function does, a struct does, etc. And so we go through, so at the head of the AST is a cursor that's of type translation unit, and then it has children, so also cursors, and then you loop through those. And each one in turn, you translate differently. So I had a big switch case in which you're just switching the cursor kind. They can't use the word type here because type obviously means something else in the language. So each cursor it can be a different kind of struct declaration, a function declaration, etc. And so, I mean, this will look familiar to a lot of people because this is not, rocket science. So I'm not reinventing the wheel here. Funnily enough, I took this version from where I hard coded the name of the struct. So this worked as long as your struct is called foo. It's like Henry Ford's car, right? You can have any color as long as it's black. Same here, except foo. And then, the struct declaration stuff, it makes sense. You take the struct, you declare the name after, of course, I fixed this. You loop over each field, which is the child cursors within it, and then translate that. And this is in a top-level translation function that just dispatches to whatever it needs to do. However, I hate this pattern. As you can imagine, this code could grow and get several pages long. Don't like that. So I actually think it's really good, and this is the reason why I'm showing it. I think every single time you see this pattern and you have more than just one line per case, I think you should do this instead, right? What I did there is I have a bunch of translation functions, each for a different kind of cursor, and I put them in an associative array, and then you just dispatch based on that. The good thing about this is you never have to write default, and you never have to worry about either, because if it's not there, you get a range error. So I use this technique in any language you can do this easily, including Python, D, etc. Because again, you never have to deal with the default case. It's handled for you by the machinery of the associative array. And also, this is a lot nicer, smaller. The dispatch becomes this, and then you can go into each individual function to see what they do with the cursors that they're supposed to handle. And then the technique here is cursors have children, and then they can have children, and they can have children. So you keep recursing the AST until you translate everything. All right, I forgot. I think I forgot a slide here. Anyway, so what you do is you recurse on them, and the cool thing about this is that I wrote some code to translate arrays. Okay. Now the thing about static arrays is the order of the numbers in D and C are the other way around. And I wrote a function to translate 1D arrays first because that's easier. Then I wrote some tests for 2D and 3D arrays going, haha, I'll get you now. The test passed. What? Turns out by using recursion, I didn't have to care. It just fell out naturally. And that's the other good thing about TDD is I didn't have to write that code either, because if I approached it assuming that I needed to deal it separately, the code would still be there handling it separately, and being complicated for no reason. Write the test, it passed. Wait, that's weird. Verified it actually, works as intended, and then I didn't have to. So that was cool. So you just keep recursing that. This top level translation function keeps dispatching to itself at the end of the day. So you go into fields, and the field might be a struct, so it goes back over here, and then everything gets handled for you, and there's no special machinery to really have to deal with that. I also want to say something about testing, because I think it's really important to basically write your own test framework for each project you work on. The test should be easy to write and to read, and you shouldn't get lost in the machinery of verifying things, okay? So this is actual test code from the project. I don't think I need to explain what it does, right? It's more or less obvious that I'm taking C code, right? Some D code, and that stuff should compile. Now, the other thing I think is important about this test is there's I think a mistake a lot of people do when they're writing things that translate code into other kinds of code, which is to write tests that assert that the output looks a certain way, right? So if I have the C code, this D code must look like this. I think that's a mistake because the compiler doesn't care how you format your code. And that's a brittle test. You change anything about the test or the implementation, suddenly you have 50 tests breaking, and for no reason. This is the worst kind of test possible, a test that cries wolf. It's broken, but the code hasn't actually broken anything. So I think it's important to show that I believe this is a much better kind of testing. What I'm doing here is instead of asserting that the output looks a certain way, I'm actually trying to compile D code that has included that header, and then doing static asserts on properties that should be true regardless of how the formatting happened. And therefore, this can never break, right? It can't. So yeah, I think this is really cool that obviously I had to write the function should compile first, but then when you do, you keep using this over and over again. And now your tests are more compact. It's readable. You don't really have to explain to people. I'm also using these quoted strings here for code. I mean, they're only meant for decode, and I'm also using it for C and C++, but the syntax is close enough that Emacs doesn't care, and it looks pretty. I mean, just try it. It's a common refrain with me. Just hack around. Does it work? Yay. Don't think about it anymore. The other thing that's good about this is also you do need to be able to debug when a test fails, because if this fails, all you're going to get is saying, yeah, I couldn't compile it. So I made an effort to, this is what happens if you change this 16 size of here to 15. So you get this instead. You said you can't execute DMD in this code. The error was that static assert wrong size of foo, and then it prints out the D code that actually translated with line numbers, so you can actually look. And you can see that the line numbers start at 53 because there's a preamble. I don't want to look at that. I mean, that's always the same stuff, and it's just going to take up space on my screen. So I think this is important as well to show how my approach, at least to testing and you know, trying to make things easier for myself. I hope it catches on. Yeah, right. So that was just talking about for recursion. I did have that slide. It just was in the wrong place. So you recurse and keep dispatching test-driven development for the win. There's another time actually which TDD saved me by I didn't have to write the code. I learned that you can return void as long you can do return function call, and that function call returns void. I didn't know that until I wrote a test assuming that that would fail, and the test passed. I went, oh, I don't have to do anything after all. Again, if I hadn't done that, I would have a static if there somewhere, and for no reason. It's a lot simpler. So, things that I learned about C even after 25 years of writing C. Once you start looking at real projects that people actually wrote code in, seriously. So apparently this is valid C code, okay? You can have a function pointer called y, and also a struct y, even in the same struct declaration. This is fine. Now, of course, in C, what happens is you have to say struct y unless you have a type def. And then you say to me, what about C++? Well, turns out C++ doesn't need to use struct whatever, but you can. So if you include this header in C++, you can disambiguate which one you mean by one saying struct and the other not. So I had to deal with this by renaming things. But I didn't know I had to deal with this until bug report, GitHub. Also, I learned that macros can have the same name as a function. And the particular case I was looking at is because so they could inline it. I guess before compilers did it, I don't know how old this code was, but the definition of the function just had the macro inside curly braces to return this, right? So that can happen. Now, the way C does with it, because think about it, if the macro is the same name as the function, wouldn't the function get replaced in the header? Not if you put parentheses around it, it doesn't. That prevents macro expansion. Who knew? But people write real code like this. I mean, if you actually try to use real libraries in the wild, this happens. So you have to deal with it. And you can't do the same thing in D, right? That declaration in D isn't valid. DMD will not accept that whatsoever. So I can't put parentheses around things. I have to rename them again. The good thing is that pragma mangle is a thing. So if I rename any functions, I could just tell the compiler how to mangle it. It'll link fine. So that's fun. Macros as well, super fun. So it turns out there's some flies in the ointment when you try to use macros as they are, because as Walter pointed out, they're C code, they're not D code. And in fact, they're not code at all, they're text. So if you have, for instance, pointers, right? We don't have arrow syntax in D, but that's easy to fix. You just, any mention of an arrow anywhere, you replace it with a dot, you're done. Size of X is now X dot size of, again, you replace it. However, what if it's not exactly size of X? What if there's a space? What if it's in the middle of something? I had to use regular expressions. I'm not proud of it, but what are you going to do? Then I found out there's a lot of CCAS in macros, like void star. Somebody actually defined their own null. Again, possibly before standardization, who knows? But they were casting 0 to void star in such a manner, so I had to deal with that too. So, okay, how do we do this? You look at the macros, you look to see if there's anything in parentheses that looks like a type. Void, void star, int, that kind of thing. What happens? Lathe files another bug because he finds something like oops4. A user-defined type in the cast. Okay, so now I have to remember all the types I've looked at before and see if any of them show up in parentheses somewhere. Okay, what about if it's a macro parameter? I don't even know if I handled that one. So this is hard, and these macros happen in the wild, and the goal is to be able to use them. I'm not entirely sure how to solve this problem because, like I said, I had an idea to take whatever the text of the macro is and then write that to a file and put libclang on it and parse it. The problem is it doesn't have to be valid code. Some of the macros are only valid code in context, okay? So you have this one here with the struct initialization. That's not always valid code. It depends on how you use it. In this case, to initialize a struct with other macro inside of it. But I can't just look at patterns like this. At least I don't know how to write a program that looks at patterns like this and figures out what the macro is supposed to do. As a human, I can tell, especially because of the name. But I don't know how to write a computer program that can do that for me. For instance, the braces might be a function declaration. I've seen macros like that, just to write code for you. Which one should I do? I don't know. And also, if I have a macro with a bunch of parameters, what are those parameters? Are they numbers, strings, quoted strings? I don't know. As a human, I could probably guess and look at code examples, but the computer can't. Or again, I don't know how to do that. So this is a hard problem, and I'm not entirely sure it's fixable. And basically, I've just learned to live with some of the macros not being usable. For the most part, it seems to work, so I'm not too worried about it, but it is an issue. So does it work? Question here.
So what about like doing the correction of those macros after the macro expansion, because then you know a little more about the context in which they appear?
That was actually John's idea. Basically, look, so we can cheat, right? If the macros are never used, it doesn't matter. And if they are used, you can see how the user used them and then do that. That is an idea I'm going to explore. I just haven't gotten around to it yet. So this code here, does it work? I copied this. This is one of the tests. This works today, right now. Okay. So you can use nano message and just include that header and call into it. What else works? As an example, as soon as I get back to the slide, curl. So I look at libcurl. That was one of the first ones that I was proud to actually be able to use properly. And I wanted to make sure that I wasn't just, translating gibberish. So I went on the internet and I looked at a curl example in C. Copied the file wholesale, pasted it, and then did 3 changes. I put 2 strings on the string literals because they're not the same as in D, right? I changed fprintf to stdr, right, Ellen? And I put stdconf text in there somewhere. Those are the only 3 things I did to the C code. It runs exactly the same. Include python.h. That works. Macros and everything. Writing a replacement for PyD using this. And the good thing about this is it will just work. For instance, when Python went from 3.6 to 3.7, PyD started crashing. And the reason for that is they added a member to one of the structs in the header. And of course, you have to update the daemon bindings by hand. This would not happen here. It would just be part of the build system. Header change, go, boom. Oh, okay. I was wondering what you're doing there. So, it would catch this kind of errors, which, we had it crashing first. Then I had to figure out why. Then, look, I had to actually look at the change logs for Python, basically, to see what happened and why it was crashing, which is not what you want to do. I managed to come to the C standard library by just including stdio and using printf. That worked. malloc as well, free. I didn't try anything after that, basically, because, it works, ship it. So, except for bugs, yeah, it works. I mean, right now, you can probably include whatever C library you want to call and use it in D. I mean, Robert mentioned that the other day. He just used DPP to translate the header files and he was done. It took a little while, but it works. The interesting thing about this is, first of all, of course, this is, I think, monumental, the fact that you can just call it to C easily as this now. If I had this at the time, I might have tried to convince the team to write the test in D. And the other thing I realized the other day that I still need to write a blog post about is, if you combine this with autorap, the easiest way for you to call C from Python is D. Translate the headers into D, reflect, generate, off to the races. Build system detail at that point. So I think this is huge. Yeah, this is actual code from that project I was mentioning. You just include Python. I thought it was really cool. I could determine if it was Python 2 or not by using D on a C struct. Does this type exist? Oh, Python 3 then. And then you can use this in static ifs and stuff like that, which is a lot nicer than any other way you could have thought of, right? And yeah, I didn't show the rest of the code, but there's macros in there as well. I basically demacrify things by, in this file, using either a template mixin or some kind of thing like that, and then expand the macro in there. So then you can mix in that template because it was supposed to be code generation. Some function-like macros, I basically turned them into a function by writing the function and then return expand macro. So I think it's pretty cool. And it will just work. And if you need to use different compiler flags, maybe you have if-defs in those headers. Maybe there are options to using Python that you want to reflect in the library. You can't do that with normal bindings unless somebody writes version statements with static if and keeps those in check. Here, it just works. Just pass -d whatever to DPP and it'll work. So the holy grail for me would be actually to supplant C++, but being able to do that. Okay, just include a header from the standard library and then use the C++ standard library or any other C++ library out there. It has to be this easy because or else people aren't going to use it. Nobody's going to consider moving away from C++ unless it is this easy. So I think that this has to happen. And never mind the standard library. What about Qt? What about Eigen? I have a friend of mine at CERN. He said, "These sounds really interesting, but I need to call into Eigen." I went, "Well, yeah, you're out of luck. There's no other way you can do it. Heavily templated library. No other language can do it either. So it has to be this easy, but I'm trying to get there. But it turns out, who knew? C++ is a teensy-weensy more complicated than C. Somebody should have told me that. Also, libclang is not everything it's cracked up to be, it turns out. For C, it's fine. It's got all the functionality there. But for C++, there are a lot of things that are missing because nobody's needed them except me, I guess. So their C++ API is obviously going to be able to do everything because it is a C++ compiler, but whether or not that's available in the C API is a different story altogether. So for instance, there's no way to query for const extra. It'll tell you it's a const value, but it won't tell you it's a constant expression at all. No way in the API. So what do? I cheat. I look at the tokens, and if const extra is in there, enum. What are you going to do? It's ugly, but it works. There's no way to get a struct's template parameter, so I'm bending over backwards right now to get things to work, especially with template specializations. It's an absolute nightmare. Then you have to have an algorithm to output either a destruct or a class because C++ doesn't have the distinction. So now you need to look at how this type is supposed to be used. I haven't done this yet, but I'm pretty sure that it's enough to use class if and only if the type has virtual functions, because I can't see how it wouldn't be a class otherwise. There might be some weird hybrid types out there. Let's just pretend they don't exist. They probably don't. I think that'll work. But certain things can't be translated at all. For instance, its reference from the standard library from type traits. I was trying to avoid type traits, but it turns out as soon as you include the C++ header, you're including type traits, whether you want to or not. And I can't write this in D because there is no such thing as a reference type. This is a template in C++ that's specialized for references. I can't write that. I can't. There are no reference types. And so if I can't write that, I immediately realize, hang on, this is probably going to be used in Sphinx somewhere. I can't write that either. I don't know how to fix this. I'm going to have to see. But however, I think there's a silver lining in the fact that D is the only language that has any hope of translating any of that. Because I looked on Google today, template specialization languages, and since it didn't show up on page 1 of Google, it doesn't exist, as we all know. The universe is contained in page 1 of Google. So there aren't any other languages that can do this. We can't even, think about it anywhere else. So D at least has a hope. How? I'm not sure. This is going to be interesting. I mean, as a human, I can look at enable if and figure out that this is a template constraint. Can I write a program to do that? I'm not sure. I can hack around the C++ standard library. So we're doing this at work right now because we have some code written in C++. We want to call from D. So we're just ignoring boost in the standard library altogether, saying ignore this namespace, ignore namespace stud, ignore namespace boost, just hand me everything else. So what we do is, in this case, there's a function that takes a reference to a const vector. We ignore it. There's vector nowhere, and then we declare vector ourselves like this. So and then obviously the member function, and this works reasonably well. I'm speeding up now because I'm running out of time. Well, I'm nearly the end anyway. So, in conclusion, programming is about the beatbacks, okay? The apes ruin everything, but we have to work with them. So, if we don't take them into account, it's not going to work. If you're arguing, you're losing, so don't argue. Just make an easy transition for them, and it will be much more likely to get adopted. I've tried to out C++ here. I'm trying to replicate what it did to succeed the way it did, and be partially successful. And go forth and include.
All right, guys, you know the drill. Raise your hands if you got a question. I think Stephen over there was first.
So I saw you had line numbers starting at 53. Have you considered putting #line into
That was just for the test. That was just for testing purposes. So the test will take the C file, translate it, take that decode, write it into a file, and then run the compiler on it. So that's the result of translating. That's what those liners were.
So when you actually call DPP on a file, it gives you the original line numbers from the C files and the.
Oh, I see. Yeah, that's interesting.
All right.
Yeah.
Right. There's a very similar problem in like Python, for instance, where you have the exact same problem. You want to be able to talk to existing C++ libraries. You want to do Qt bindings. You want Qt bindings. You want to do what you said. I forgot the name of that mathematics library. Whatever bindings. Yeah, thanks. And exactly. And so there's a bunch of existing interface generators for API bindings like Swig or SIP on the Python side.
Swig is hell.
Yeah, I know, believe me. I look at that myself, but is there any hope to getting that sort of technology up to shape because potentially you could get other languages invested in the effort?
I don't know. I'm not entirely sure what the question is.
I mean, is there any hope for? Sorry, I mean, is there any hope for technology like Swig, or does D have to go it alone?
In my experience, no, because we used Swig at work to bind C to Python, and it was a complete nightmare. I mean, the manual work we had to do was off the charts. And again, if I'm a programmer, I'm lazy. I don't want to write anything. I want to tell the computer to do it and have it figure out.
Stefan?
Have you figured out, have you tried to patch libclang to export the functionality you need through the C interface?
I'm going to have to at some point. I'm just going to have to send pull requests their way because nobody else is going to do it.
Yeah, that's going to be fun.
Right. I'll go over there first.
Translating a lot of C++ code, one problem I've really run into is a class that has virtual functions that is basically kept on the heap. And I don't have a good translation for this in D, and I wonder if you've run into this problem.
Class? Just use a D class.
No, I'm on the heap.
Yeah.
Okay. Sorry, I meant on the stack. I mixed it up.
I guess, well, but that would be in user code. That wouldn't be the interface though, right? I mean, if somebody's using that type usually on the stack, you don't have to from D. And even if you do, you could use in place.
It's fine until people start returning it. Like C++ doesn't really enforce memory protection or anything like that.
Yeah, that's a problem. Especially because right now, I mean, even in the latest compile, you can declare a copy constructor, but the bindings don't quite work yet. So returning and passing by value doesn't work right now.
You can have a class stuck on the stack if you just use the scope storage class.
Yeah, and then in place it, sure.
It seems to me like if you're looking at, sorry, let me restart. How do you handle inlining? Specifically, how do you handle functions that are declared inline and contain the body inside the header? Like, is there any hope to do this without doing the entire C++ compiler?
Well, I'm crazy, so I've punted on that. But basically, my plan was to translate the body. Because I'm nuts. I don't see any other way. What I've been doing so far is forcing the instantiation, just the same with templates, basically. So I have a C++ file or C file. I force instantiation there and then link. So that's the workaround I'm using right now. But the plan would be to translate. Because that is a cost, right? That's not exactly the same.
All right. Anyone else? No, looks like we're finished with questions time. Then thank you, Attila, for your talk. All right, so come back here in about 6 or so minutes for your next chance to win a D-Man shirt. All right, I think we're all ready to go. Whoa, a couple of stragglers up the back. Come on, don't struggle. You're not going to be able to win one of these D-Man shirts if you straggle. All right, that's the last straggler. Let's go with a question here. All right, here's another one from Walter's Knowledge Bank. What was the inspiration for underscores in integer literals? Not Java, but there's a hand up there. Correct, it is Ada. So this guy gets a shirt. Woo. All right. Okay, but now we need to get on with the talks here. We have Edward Stanilow. I think I mangled it again.
No,
Anyway, he's going to give us a talk about class hierarchy and the like. So round of applause, please.
Hello, everyone. I'm very pleased to be here. Today, I'm going to attempt and put forward to you a new way of viewing the class hierarchy in D. So the way I view it, this is my elevator pitch towards you. The catch is the elevator is only going to take 20 minutes to get to the destination. So let's get going. First, let's talk a bit about the current situation. So as I'm sure all of you here already know, in the D programming language, we have object as the root of all objects. And the main interest of us is that object defines 4 methods. It has toString, toHash, opCompare, and opEquals. And I'm pretty sure that at first they don't strike you with much, but the issue with those 4 is that they predate the introduction of function attributes. So they predate the safe, purity, no GC, and no throw. And also they don't work with qualifiers, right? So we don't see any const or immutable up there. So in order to stress it out a bit, if you have in your day-to-day work, let's say you keep an array of objects, and your task is to find a certain object in this array of objects, then you'll be hit by a couple of problems. First, the opEquals operator is not able to work with const objects, right? And since this is a search function, it's pretty obvious, and it's always right the recommended way of like passing things with const. As Attila was saying earlier, this is his way of like preferred way of doing things. The second issue is like we don't have attributes. So even though this function has no reason not to be, no throw, no GC, pure and safe, it cannot. But let's say a user is going to define his own class, improved object that extends from object and overrides all those methods. And he adds the function attributes, but still this is not enough. So the first issue is that opCompare and opEquals, they will have to continue to take a const object instead of an improved object, and that's because of covariance. So what covariance states is that a derived class, when it overrides a method, it cannot ask for more from its parameters. It can ask for less, but not for more. The second issue is that toString, it has no way of meaningfully implementing a no GC version, since it has to return a string, and it has to be something of meaning to the user, so it's going to probably have to convert some runtime information. It most likely will have to call the garbage collector or try to find some different ways. So it's pretty complicated. There are some more issues. So the first one is the object class also has a static factory method that enables you to create an instance of any class. The problem with this factory method is that it creates a lot of code bloat. In order to make it work, it needs to know the type info information of every class in your program in order to maybe call it in the future. And there aren't many calls in Phobos, for example, that actually take advantage of the factory method. So this should be opt-in at best. The second issue is this mutex field. At first, I didn't show it to you. So object has a hidden mutex field that's implementation defined, and this is used for synchronization. So when you want to ensure exclusive access in a code area and a code block, you would call synchronize, and this will effectively take this mutex. So this has a couple of problems. First, it doesn't play well with immutability and purity. There are, again, few cases where the mutex is actually used, so it should be opt-in at best, because otherwise there are a lot of classes that just take up some extra space without ever using that space. And another point is that because this is a field, it introduces a fragile base class problem. What this states is that a seemingly unrelated change in the base class could possibly lead to hard to discover bugs and breaking changes. So we want to do better. And in order to do better, actually, driving home the point is that we have two design goals. The first one is to allow the user, he or she, to pick the methods that his type must implement in order to best describe the behavior that his type is able to fulfill. And the second one is the root object needs to be able to work in attributed code, as it was the case with the find function. So searching for a good design, we decided to look at other languages, other object-oriented languages, and see how they treat the same problem, right? So what is the way of defining the root class, and what's the interface that this class exposes, and how do they treat the comparison, for example? So the first one that we had a look at was Java. As many of you know, D and Java have a lot in common. So object is also the root of all classes. The object in Java defines the equals, hash, and to string methods. Those are similar to up equals, to hash, and to string, right? It has a get class, which is similar to how we use type ID on classes. And most important, it has a call method that's similar to the factory one. And most importantly, it also has an object monitor, right? A lot of similarity. Looking at C#, though, again, is the root of all classes. C# has a much smaller interface that it imposes on the classes that extend from object. So it only has to hash, get type, and to string. But the major difference here is that C# went a step further and removed the monitor object from the root object, and it defined it as a separate monitored instance that extends from object. So this is closer to what we want to achieve. The next candidate we had a look at is Rust. And if you are like me and don't know much about Rust, you'll probably be surprised by the next things. So the first one is Rust data types are completely unrelated. So you don't have subtyping and inheritance. The way Rust establishes relationships between different types is by using traits. So a trait is just like stating, hey, this is the behavior that I'm capable of doing. The other name that you are probably most familiar with is the traits are exactly like interfaces, more or less, right? So, and we're doing something similar with introspection and structs, right? And all the compile time features that D has. But we can emulate the same behavior with objects as well. So let's have a look at how a trait in Rust looks just for like completion, right? So you define this trait quack, it states, hey, I know how to quack. You have a struct, and then you just say, implement the quack trait for my struct. And now, yay, we can quack all day. Yeah. So now, my proposed design, well, our proposed design is, we'll have a root class that's going to be an empty object, and this is going to be at the base of the hierarchy. And we'll call this proto-object. And then we'll define interfaces that expose the desired behavior, right? Because it can be argued that at the end of the day, you're only interested in what your type can actually achieve, and you don't have to have it baked into the object, right? So how this will look, we'll have at first a proto-object, as I said, that's going to be the empty class. Then we'll have a synchronized object that will have the mutex field. So if you desire to have this mutex, then you will extend from synchronized object. And then object, as it currently is today, is going to extend from this synchronized proto-object. So what this achieves is it gives us a lot of flexibility going further without creating any breaking changes. So this is pretty good. So how this came to be? Well, Andre had the following observation, as he was saying yesterday, right? So object has two roles. The first one is the root of all classes. And the second one, when you don't explicitly state what is the parent of your class, then that role is taken by object. But object doesn't necessarily have to be the root of all objects, right? So this is going to be taken care of by proto-object, and the code will continue to work because if you don't define a parent, then we'll just leave object doing his own thing. So going forward, the recommended way is to inherit from proto-object and then implement the interfaces that expose the desired behaviors. So in order to replicate the existing way of working with object, we start by defining 4 interfaces. Ordered, which implements the op-compare, equals for equality, hash in order to implement the hash method, and stringify for lack of a better name, but we can vote for it, right? That exposes the toString method. So the first thing to notice with the toString is that we opted for a design that takes a delegate that you pass what you want to output, sort of like a sink, right? So this is a way of avoiding the GC problem. Now, let's talk a bit about ordering. Yeah. I tried to like make it fit the slides. Right. So before I go into how the interface looks, I want to go through the why and what we did. And I promise this is the most complicated slide, and then we can all exhale successfully. So first, at some point when you're going to compare 2 instances of a class, it's going to get lowered to a call in the runtime. And we'll compare 2 types, class 1 and class 2, and we don't know much about it. And we try to figure out at first, what's the most derived part? So we're making an assumption at first, maybe they are somewhat related, right? Disclaimer, this code doesn't compile, right? The first alias is just like I had to fit it in the screen. So now we're looking at a bit of extra information. So we're comparing the pointers to the V table. So if the pointers are equal, then it means that we have the same dynamic type. And if we have the same dynamic type, and the dynamic type is the same as the most derived one that we've previously figured, then we can attempt and bypass the downcasting or the runtime and explicitly cast to the most derived one. So we're able to then cast to our most derived part and then call the op-compare. If we don't have this information, well, if the most derived op-compare method doesn't take another most derived, it probably takes something else, then we'll leave it to op dispatch. If we are out of luck, so either the types are of different types or they have the same type, but it's not the most derived one, then we'll leave it to op dispatch. So to dynamic dispatch. So in the worst case, when we get to dynamic dispatch, we're going to have to compare 2 proto-objects. We don't know anything about them, so what can we do? Well, the first step is to check if it's about the same object, and then we're done. If not, then we're going to have to do a dynamic cast to an ordered interface, and then call and leave it to the dynamic dispatch, then to a call to op-compare, and the argument is a proto-object. So this is the interface. Our interface takes a proto-object. The reason why it takes a proto-object and not an ordered is that most likely in your implementation, you are going to do a dynamic cast from proto-object to your desired type. And if we would have took an ordered, then instead of doing only 1 dynamic cast, you would have ended up doing 2 dynamic casts. So it's more of an optimization. So ordering implies that it follows a total order. What it means is that first, for any 2 objects A and B, only one of the following 3 stands true. So it's either A is less than B, or both A is equals to B, or A is greater than B. And the second one is that it's transitive. So if for 3 objects A, B, and C, if A is smaller than B and B is smaller than C, then A must be smaller than C. So now let's look at an example. So suppose you're implementing your class, a book, and so you'll have a unique identifier, the ISBN, and a format. And the way to compare, because a book is uniquely identified by its ISBN. You don't care about the format, right? So you just look at the ISBNs. I was surprised. I remembered I had an animation here, but apparently it's gone. All right. Okay. So as you can assume, this is going to probably generate some boilerplate for the user. And boilerplate is boring, and that's why we want to aid the user. So in order to do this, we implemented this mixin implement ordered. What this basically does, it's in the most raw form, it goes through all your fields inside your class and it compares it with the right-hand side, right? So in order to use it, you just like mix in the template mixin, and this will automatically generate the op compare for you. And then this is going to go through your fields and it's gonna compare them. And surprise, surprise, those are not equal. And this is the correct behavior in this current format, because as I said, you shouldn't look at formats, right? But the raw implementation will do this. So again, we thought about it. So what the next step is that it allows you to provide it with a list of the names of the fields that are significant in the ordering operation, right? So now we're telling it, hey, I'm only interested in the ISBN. And now we can see that the comparison is the right one. But there's more. What if you want to provide a custom comparator instead of using our default one, right? So we are providing you with this opportunity. Again, in the list of named fields, you can stick next to the name of your desired field what comparator you should use. And you can use either a lambda or you can give it a name function. Yeah. Got a question?
So floats don't give a total order. And if you go look in one of the scariest bits of Phobos, which is SSE TypeCon's proxy, you'll find that the implementation of opcomp there returns a float instead of an int, because it needs to return nan for cases where things are not, where in order to be where they're not orderable. And this means that you can do a proxy of a float and it works. Does this support the same mechanism, or could it be extended to do that maybe?
So we thought about that. So just for everyone, so the reason why float is not a total order is because you cannot compare not a number, right? So nan cannot be compared with another nan. The way I would suggest going forward is kind of like replicating what Rust is doing. Got to speed up a bit. So in Rust, they have a partial order, and that's exactly for this. And it states like, hey, we're not a total order, we're a partial order. So it's kind of expresses the clear intent to the user. Okay, so just to manage to go through everything, right? Okay, there can be made a case that most of the time, actually, what you want to do is you want to exclude only one of the fields. So out of a list of fields inside your struct, only one is insignificant, or a couple of them. So instead of having to type all the others, you can just type the exceptions, right? So this is the final form of the super cyan here. Okay, so now food for what?
Did you consider using a UDA on the fields that you don't want to do that to instead of this?
No. Yeah. So now another thing is like food for thought, because you kind of went ahead of me here. So based on the same thing, so there are some classes where some types where comparing doesn't make sense, or maybe you cannot cast, right? So you cannot dynamic cast here. So from proto object, you attempt to dynamic cast to the book, and it's not a book. And in the previous example, you would have returned a 1 when comparing to null, which this is kind of like you're saying, hey, I'm greater than the other guy, whereas you actually weren't able to compare with the other guy, right? Because you're comparing pears with apples. So float here would provide in with another interesting feature, because you have two options. Either you throw an exception, like non-uncomparable types, or you could return not a number, and this gives you some extra information. Now, equality, as you will see, the interface stemmed from the same issue. At some point, we will, in the worst case scenario, we'll have to compare two proto objects, and that's why the interface takes a proto object. Equality must respect the following contracts. So it must be reflexive, so any object must equals to itself. It must be symmetric, so if A says it's equals to B, then B must agree with this condition, right? And transitivity. And again, for equality, and in order to aid the user with all the boilerplate that he would have to type on his own, we provide the same thing. As Scott was saying a couple of editions ago, consistency, consistency, consistency. Right? So it implement equals has the same roles as implement ordered, and implement ordered equals except. The hashing interface, again, it's simple. It has all the attributes. There's one catch. The first is like, if for equality or comparison, you can quit early, where the first time you encounter a field that's not equals to you, or with hashing, you have to go through all your fields, right? So I'm not stating anything that's rocket science. I'm just like, don't forget about this. And another thing is like, because now we have a lot of power, you as the implementer, because you can decide if you want to implement the op compare or op equals or to hash separately, you must make sure that if you go implement each of them, they must agree. What I mean is if two objects say that they are equal, then their hashes must be equal as well. So don't forget about that. It's a common mistake in object-oriented programming. Again, for hashing, we have the same mixins that aid us. And as I said, the string takes a delegate that the delegate also needs to have all the attributes that I just like try to make it fit the screen. In conclusion, we have a proof of concept that it's both flexible and it's able to work in attributed code. And we have ways of reducing the code bloat that the user would have to type. So if you want to check out the dip, it's on this branch over here. And the code changes for both the EMD and the runtime are also in this dip proto object branch on my forks. Thank you for your time. And I hope next time we meet in an elevator, you won't run away. I'm here to answer all your questions.
Yeah, I think we've got basically got time for one question, so make it a good one.
Okay, one of the core problems with all the functions on object is not that it was done before we had attributes, but that no specific set of attributes is good for everyone. For instance, op equals being const is a real problem if your object is doing any caching, because you may not, particularly if it lazily creates value, because at that point, it won't have created it yet necessarily when you call op equals, and so that object can't make it const. So why would you have interfaces here as opposed to just using templates and looking for the correct function signature?
So the best way to go with this, in my opinion, is as well to go with templates. But this is, we're trying to also improve on the lacking parts on classes and objects. So
I mean,
I know it's not a sufficiently good answer probably, but it's the best.
I don't see why we need the interfaces at all, because if you just have the appropriate template constraints and the code is templated, then it's a non-issue. It will work as long as the functions match up.
Well, okay. Yep. All right.
So to answer that question, at the level, it must be understood that there's a tension between generic code using parametric polymorphism and generic code using inheritance and overriding. And at some point, you got to resolve that. You can't, if you sit down and try to do it pen on paper, you're going to realize real quick that you got to choose one or another. You can't choose both. There's no magic that templates can do that's going to undo the type erasure that occurs whenever you convert from a supertype to from a subtype to a supertype. So we chose const there because it seems like the reasonable thing to assume people are going to need. It's not expected that comparing two objects is going to write to them. And I understand that this hurts 90% of our users, but it's obvious that the other way would also hurt 90% of our users. You see my drive, right? So I think we can't have it both way, and we chose const, and we're gonna go with it.
All right, well then that's it for now. Thank you, Ian. Round of applause, round of applause. And the next speaker is also a half-hour talk, so we're going to get him up as quickly as possible. So just mingle in this room, don't go too far. All right. I hope you all didn't go too far because we are ready to go. So we're going to kick this off. Alexandru Militaru wants to talk about D for a safer Linux kernel. So round of applause and off you go.
Hello everyone. My name is Alexandru Militaru, and this is my very first talk. I'm very happy to be here. This presentation is mainly based on the work that I'm doing from my bachelor thesis, where I am using the deprogramming language to strengthen the security of the Linux kernel modules. This talk would not have been possible without the great support that I've received from my scientific advisors, Edward and Răzvan, and I want to thank them. D is advertised as a safe and fast systems programming language. We know it's easy to write an operating system in D, and many projects have proven so. We have PowerNex, XOMB, and Trinix. However, we don't know how hard or easy it would be to use D code into the Linux kernel. Why would we do that? Because, believe it or not, the kernel is still struggling with many buffer overflows and other ugly bugs caused by faulty pointer manipulation. Many of these bugs could be avoided if the kernel would be written in a language with array bounds checking and other safety features. In this case, D can be of great use, at least theoretically speaking. To find out how it is really like in practice, we decided to introduce D code in the existing C code base of the Linux kernel. But before doing that, we wanted to be sure that these two files together in a greater object. We had to write a kbuild file where we instructed the kernel to place these two files together in a greater object. As you can see, the D object has a special extension, namely oshipped. By using this extension, we are telling the kernel build system that this object, it's already compiled, and it doesn't have to compile it anymore. It has only to link it with the others. So we had to precompile our D object, and we used DMD along with the -betterC flag because we wanted to get rid of the D runtime because we can't use it in the Linux kernel. After was fine. About adding a parameter to our module, since almost every function in a kernel module has at least one parameter. So we added one parameter in C and then in that function in D. We recompiled, and when we inserted our module, this wasn't working anymore because of an unknown symbol. This symbol was the global offset table. We thought about trying to recompile with LDC and see if this behavior gets replicated. As you can see, no global offset table, and it worked just fine. We didn't discover why the DMD compiler was inserting this symbol, so in the interest of progress, we decided to move to LDC. And so everything you'll see from now on, it's compiled with LDC. Having the proof of concept done with the dummy module, we wanted to introduce decode in a really hot part of the Linux kernel. But the kernel, it's a huge beast, and there are many parts worth strengthening in it. However, there's no place like drivers. A research published at NDSS 2013 measured different parts of the Linux kernel and discovered that the drivers represent the most significant part in lines of code of the kernel attack surface. Considering this, we thought that porting a driver, it's the best place to start. So we began to seek a suitable driver. In our search, we followed three criteria. First, the driver had to be relevant for the kernel community. The second was the driver had to be easy to test and benchmark. And the last one, the driver had to be of medium size in lines of code. Having these three criteria in mind, we chose VirtIO.NET-C, VirtIO's Nurture driver. The VirtIO's framework is widely used in virtualization, and VirtIO.NET-C, it's one of the most complex devices supported so far by this framework. It has 3.3 lines of code, K lines of code, and being a network driver, it's easy to test and benchmark. Having the driver chosen, we wanted to venture to the process of porting, but before doing that, we needed a plan. First, we need to port the data structures and then to port the functions, the driver's actual code. Having the driver ported, we could make the first set of benchmarks. The following step was to deify the code to add the D features in the drivers. And the last step was to assess how the features affect the driver's behavior. So the first step was to port the data structures. We needed the data structures because the decompiler had to know the structs layout in memory to be able to use them. Some structs were defined right inside our driver, but the largest part of them came from the header. As Attila said, the level of branching in the header files, it's huge. And there were many structs to port, and we tried to avoid this step by using DPP. However, we encountered some problems, and we were not able to use it. And in the interest of progress, we decided to port the struct by hand. We thought that porting structs by hand won't be that hard, but 1 month later, we will still porting structs. This for sure is because of the high level of indirection and branching in the header files but also because of some problems that we encountered. One of them was the empty struct. In C, this struct is an incomplete type, and its behavior is undefined in modern C specification. However, GCC permits this kind of struct, and its size is 0. In D, the size of this struct is 1, and this is great because it's part of the language specification. However, when interfacing with C, this is problematic. Consider the following struct. If struct empty, it's a really empty struct, then the D version and the C version of bigger struct will have different sizes and layouts in memory. So you have to be very careful when you have this kind of struct and you are trying to interface with C. Another problem that we had was when we tried to use bit fields in D code. As you know, bit fields are not, D doesn't have bit fields. But we could avoid that using the bit field implementation from the standard library. Another problem that we had was the fact that we can't introduce a version inside that bit field instantiation. But we also managed to avoid that by using string mixin. That evolve version template, it's returning that string if config something is defined, else it returns the empty string. So we replicated this behavior from C. After we ported the structs, we began to port the function. But after we ported the first function, our kernel was crashing. After some hours of debugging, we discovered that the parameters that were used inside the functions were completely different than the one that were passed when the functions were called. This bit ABI calling convention is that if you have a function foo with A, B, C, then the caller will place the parameters on the stack in the following order. And the callee will be able to access them as in the following figure. However, the parameter mismatch was caused by the fact that modern 32-bit Linux kernels are passing the first 3 parameters in registers as an optimization. We've learned that the 32-bit kernels are compiled by default with the mreg parm equal 3 GCC flag that tells the kernel to pass the first 3 parameters in registers, and if they are more, to place them on the stack. How we solve this problem? We compile the kernel for 64 bits. On 64 bits, the kernel is using the standard System 5 calling convention. That means the first 6 parameters are placed in registers, and if they are more, they are placed on the stack. 64 bits, LDC is doing the same. Another problem that we had was after we ported the first static array. After we've done that, we could no longer insert our module because of an unknown symbol. This symbol is the name of the assert fail function from the C runtime library. We've learned that since we used the -better C flag for compilation, the asserts are altered to call the asserts from the C runtime library instead of the D runtime library ones. And this is great. The will remain undefined. Our workaround was to define our own assert function with a minimal implementation, a call to the kernel's panic function, and a warning message. We prefer this instead of a security breach caused by an undetected buffer overflow. Another problem that we had was when we ported when we wanted to use function pointers in D.
we had an array of function pointers that we iterated over it and initialized each pointer with the address of a function. After we've done that, we could no longer insert our module because it had an invalid format. And the unknown relocation was issued. When we looked at the relocation section of that function, we discovered that when the addresses of those two functions were taken, this type of relocation was issued, GOTPCREL. This type of relocation is using the global offset table. Now let's look a bit at the function that the kernel uses to resolve relocations. It's not very hard to understand what's happening here. This function has a switch that handles many types of relocation. However, GOTPCRL is not one of them. And this switch will end on the default case, and the unknown relocation error will be generated. So we had to do something to avoid this. Our solution was to create two wrapper functions in D that just return the addresses we needed. And we use them in D like that. And now we had two different types of relocation, PLT32, one that the kernel knows how to handle. And when we ported the first global array, we had this array of structs in C that we ported in D like this. There were many functions that were accessing this array, and one of them looked like this. We inspected the relocation section of this function and discovered that the array access generated once again this type of relocation, and we already knew that the kernel it's not able to handle this type. So once again, we had to do something to avoid it, and here the problem was that this array should have been placed in the raw data section, but it is not, and we don't know why. But we've tried to get it there by using first immutable, and then and the problem persists. Then we tried to use enum for that array, and a type info error was generated. What really solved the problem was to make the array immutable enum, and so a new type of relocation was generated, and the array was placed in the raw data section. Another thing that solved the problem was to make the array enum and specify the size. And this type of relocation was issued again, and the array was placed once again in the raw data section. After we ported the structures and the functions, we had an up and running D-written module. So we could make the first set of benchmark. As a reminder, our module, it's a network driver. So to benchmark it, we created the virtual machine using QEMU and measured its network performance using iPerf3. Basically, we created 3 client-server connections, host to guest, guest to host, and guest to guest, and we sent packets for a fixed period of time to see what bandwidth was achieved. Then we've done the same for the C version of the driver and compare the results. Here they are. As you can see, the D and the C version are almost the same. The D-written one has a small decrease in performance between 1 and 4%, but considering the fact that there are still some bindings, That means D functions that only call C functions that could not be ported. This difference is explicable and also fairly insignificant. After we've done the first benchmark, we began to add features in the driver's code. There are some things to do, but we've done some of the most important ones. One of them was to add bounce checking, and this is a big plus for the driver security. Let's have a look at this function. Here, an index, it's magically computed, and then this array is accessed. So simple and remarkably unsafe. To strengthen the security of this kernel module, we had to add bounce checking everywhere this kind of access was done. But how do you get bounce checking when you have the parameter of the function, a pointer, and this same queue that is accessed there, also a pointer? We don't have any information about length. After we analyzed our driver, we discovered that there every struct vernet info it's allocated along with its queues. So here is the length information that we needed. To use this information, we created the wrapper struct that had two slices, one for the send queues and one for the receive queues, a pointer to the original vernet info struct, and the zero length array that we used to for container auth. Then we've modified the function where those queues were allocated. We declared a pointer of the type of our wrapper struct. We allocated memory for it. And then each slice got a chunk of that extra memory. And then we made the old queues point to the new ones from our wrapper struct, the ones that also have bounce checking. Now let's see this wrapper struct in action. Remember this function? Now it's safe and also has bounce checking. Our change was simple but effective. Everywhere a queue was accessed through a vernet info struct, we brought our wrapper struct using container auth, and then we modified the access to be done on our queues that also have bounce checking. Another thing that we've done was to use templates where C was using void pointers to achieve generics. We had this struct in C that's this is a representation of a device in the VirtIO framework. It has a void pointer that holds a reference to something. In our driver, this reference was always to a vernet info struct. So everywhere a vernet info struct was needed, it was extracted in the following way. And this works because in C, the void pointers are automatically converted to any other type of pointers. But this is very unsafe. You can be sure that this void pointer, it's really a pointer to the type you think it is. In D, this is done with a cast. Also, if you don't make a cast, it won't work. So why don't use a template instead of this void pointer and also have the type system on our side? What we've done was to template this struct, and then we made an alias, and then we measured how many casts of this type were done, 13. After we've used the template, 0 casts, all gone, and the driver is also safe. After we added some features, we also made the benchmark, the second one. As you can see, the D and the C version are pretty much the same. There's a very small decrease in performance between 1 and 4%. As future work, it would be nice to use link time optimization because there are some functions that are still in C and the compiler can't inline them. It also be nice if we would write down the issues that we've encountered and hand them to the D community. Maybe we can work together to solve these problems. And another great thing would be to make DPP work, because this would save a lot of tiresome work. As conclusion, D can keep up with C in the Linux kernel, but being through all this process and seeing all the issues, we think it's better to write a driver from the scratch in D. But our project also proved that it's possible to port one incrementally. And a compiler switch for the issues encountered for relocation in special would be very nice. Thank you for your attention.
Alrighty, and again, we have one time for one question, and it's from Walter.
I suspect that the slowdown is caused by, instead of calling functions directly, you're calling through function pointers. That would incur a little bit of slowdown, and they just, completely explain why you're seeing that slight decrease in performance. The second thing is all the issues you had in there are solvable. So I'm going to be a broken record and say I need a Bugzilla for each of those issues, and then we can attack them one by one and get them resolved.
Cool.
All right, thank you, and thank you. Okay, so up next we have the hackathon. Now this needs a little bit of attention from the people, not the hackathon, the lightning talks. And getting ahead of myself. This needs a bit of attention from everybody that is doing a lightning talk. We need you to see Mike, who will be heading out there, just outside that door. No? Okay, go see Mike up the back first, and then he'll explain what I'm about to explain to you. All right, so everybody else, you got 5 minutes. Lightning talk, guys, do your thing. The mic on. One thing as well, I've got, guys, I've got the podium mic turned on, so you don't need to hold the microphone. So if you need to walk out though, you've got a microphone. Okay? Sweet. So yeah, there are guys that want to standing on the podium, so both of the microphones are on. Cool. I think we're good. All right.
Maybe you need somebody else who's in front of you. Joseph is in front of you.
I'll still do laptop. All I do is just the browser. Okay,
I suggest in that case you use Chromium, just because I have a bunch of JavaScript blocky things on. So I like it. Oh, it's up high. Right, everyone, we're going live. Okie dokie. We're all ready? No, we're not. Please take your seats. All right, so we've got the lightning talks happening now, and we do not lie. These are going to be lightning talks. These guys are on a strict 5-minute timer. I'm going to let them know when they've got 30 seconds left. When the time goes 5, I'll yell out time's up. Their mic dies. Everybody applauds. Next guy comes on. And since we got a number of, hold on.
And no questions.
No questions. No questions, unless the guy finishes at 4 minutes, and then you have time for one, but that's it. Otherwise, 5 minutes, you're out. Okay, so with we should get this puppy on the road. We've got Stefan up first. Hit it.
All right. I have a few tricks to debug CTV code, and one of the tricks to debug CTV code is to build your own error stream, which you can then return as a string. If you have this code, this should just work with the two functions. When I compile it, it doesn't. Okay, that's not great. It has to be static assert when it's used out of here, but yeah. But now it should when I add the semicolon. This works. If I do it with the wrong value. I don't want a micro break now. It will give me a static assert. I cannot deal with this, and it gives me the value that it cannot deal with. And when I now want to do the same thing with a float instead of an int, something surprising will happen, or maybe something that's not so surprising. So now I enable the other function and instead of the thing I want to get, I get an uncaught CDV exception, and it tells me it can't convert floating point values. Now, I have a compiler backend, a complete compiler backend that works fully at CTF and supports floating point. So how do I get these error messages out? Well, there is an easy solution to that. I import a module that I wrote. It's called CTFE FPConf. And instead of toString, I have to say CTFE D2A. No, FPConf D2A. I always make that mistake, and I never played Dota. and I can't do that. I have to import the current directory, and I get an unrecognized. Yeah, that's probably what happened. What? Maybe I changed the module name. Anyone see what it is? Yeah, it's wrong. Has to be _cdv. We do that. No, don't. This is what happens when you don't look at the keyboard while typing. If you're not used to that crappy laptop keyboard, and now it tells me static assert, I cannot deal with this. And it gives me the 1, right? When you use printf, it would give you 1.90 whatever, but this thing can correctly give you the floating point values that you actually pass in. If I say 2.3.3, and of course here I have to say the same. I remove the parentheses where? Which one? Oh yeah, X. Not another microbag. And it tells me this also correctly, and this is pretty cool. We can now print floating point numbers at compile time. What is your reaction to that? Do I have a second for questions?
You have time for one quick question.
When are we gonna see CTFE? This work?
Say it for everyone, Ali.
When are we going to see this work in DMD?
This
20
particular
seconds.
thing is not DMD. This can go into the standard runtime. This uses the normal DMD. It does not use the new CTFE. It works currently.
All right, well, you got 5 seconds left, so make it count, or you can just applaud him, whatever you prefer.
Applause! Thanks, guys.
All right, so here we go. We got Reinisch is setting up now. All right, let's see how quickly he can set up. I'm not going to time you. All right, so that will duplicate. You're good to go. Good to go. Please stand by. We are having technical difficulties.
No, it doesn't work. So
Yeah, should be fine.
duplicate, it's okay.
Yeah, it's just duplicate. It should be fine. We may need help here. All right, so it's not happening that lightning quick as it turns out.
I'm sorry.
No, I don't know. It's the dude's coming up here. He can sort you out. I guess since we have technical difficulties, we can do another little one of those games that we've been playing for a D-Man shirt. Woo! No one? All right. Okay, so here's the question. It's a good one. Are tabs evil?
Yeah.
No. You were the first one I heard that said no, so you'll do. Robert, you get a shirt. Correct answer is no.
Correct answer is yes. No.
Hey, I've got the microphone. It's my answer.
This is true.
All right, how we doing over there?
Not so good. Yeah.
All right, we're going from DVI to VGA. Let's bring it back to the 80s. Oh, here we go. Hey, all right. Let me switch back to my timer and then we can kick it off.
Oh, thank you.
Okay, and your time starts now.
Okay, thank you. Well, I want to present you a recent development of the GC in our runtime. And the most important change for me is that we finally have a precise GC in the runtime, and that means it can scan the heap precisely and detect false pointers for most types. This is implemented by passing type information to the allocation functions and others, but no type information change is available after allocation. That was in the proposed precise GC I presented 2013 on DConf, so it's finally after 6 years. There's some because the change that information cannot change after allocation. The special layout of arrays is implemented into the scanning inside the garbage collector. You can enable the precise garbage collector by selecting this command line option or embed runtime option into the binary by linking the string or the string array into your binary. And for the data segment, we already have since some versions this option, and but this is only available on the Windows. So in addition, we have an open GC registry where you can link your own garbage collector into your binary and then select it via the same option. This is implemented in core GC interface. The interface is defined there, and you have to implement it. You can register it with a C runtime constructor function. It must be registered before the D runtime starts because static initializers might already allocate. But if you never allocate with the GC and you really want to forbid that, you can also redefine this register default GCs function and remove all existing GCs as well. In addition, some optimizations have happened, and my vision of workable interactive application is if it needs 1 GB of managed memory and pauses under 50 milliseconds, then it's fine. That would be a rather good achievement. We are not yet there, but with my test that parses the parser itself 100 times and throws away every AST, that's some of kind of a representative test case, and the baseline with LDC is this benchmark result, where it's especially interesting is the time that it's spent in the GC, that is more than a second, and the max pause time, that is the time that actually all other threads are also stopped, is 300, and some memory is wasted when because we so far only allowed allocation sizes of a power of 2, and we added at least one value in between without changing the other allocation strategies. And so we, in this case, the reduced memory is not that much, but it can lead up to 20% less memory being used. And there is so far mandatory cleanup.
30 seconds.
Oh, okay. So I have to speed up a bit. These optimizations lead to some removal of sweep time and recover time. This is special phases within the garbage collection, going down to about 380 milliseconds. But after that, the big breakthrough here is having parallel marking inside the garbage collector, which brings it down to
that's it. Time's up. Sorry, that's it. Applause, everyone. Markwell. Just Markwell. All right, so we got a Markwell coming up. Let's hope we have better luck this time with the equipment. Got it. Yep. BJ out. And bingo! Excellent.
Advantages of using Linux.
All right. Well, here we go. Your time is starting right now.
Well, I want to talk about type-set-oriented programming introduced in this paper. Well, most people know object orientation if you have like two types which are related. Example, a citizen and a superhero, and the superhero can fly, but a citizen can't. Then you define your method in the superhero, and if you try to call it on the citizen, then the compiler complains. However, what if you have one type, but methods that are sometimes valid and sometimes not, for example, in a file? To know which method you can call requires knowledge of program flow, implementation perhaps of your file class, and, well, you need coffee. So what these authors propose is statically checked states. For example, you have a file class with various states. A file can be closed, it can be opened, an open file can be read, etc. I've tried to make a small proof of concept of this in D. I have a class file, and I have inner classes that extend the file. And I use the compiler to match the state. I use open methods for this. Open methods allow you to define virtual methods outside of the class and then call the method related to the instance, to the type of the instance. For example, if I want to read a file, I use the above method. I initiate the file with a static method. I only expose the file base class, and I have to match the type to be able to use more advanced features. It works, but it's rather clumsy. You also need to pretty much adhere to a design pattern, and well, design patterns are bad, in my opinion. But it's funky stuff, and funky stuff is like the positive way of obscure, so that's good. And well, if you want to try things like this, just put it in production code and see what happens. That's my advice. If you're interested in the full implementation, it's on my GitHub, and the original paper is linked here. Well,
All right. Well, you've actually got plenty of time for questions if anybody has one or two.
Can we go back to the last code?
What this code actually does, we define a virtual method handle on a file. Then with some mix-in magic, we actually call, for example, the open file handle method. It then returns a new, potentially new instance of file, which represents the state the object is in. In this case, if we have a file with extra contents, then we still get an open file back. However, if the file is at the end, then we return an empty file.
All right, still cool. And it looks like we've got Amari coming up. He's up. You ready to talk? Well, you need a microphone, I assume. Let's hook you up.
Some slide as well.
Are we on? We're on.
The slide to the man with
Okay, the dude has the slides apparently, in
Yeah.
which case you're going to want this.
Yes. Back and next. I think I can
Yeah.
figure that out.
It's even like green and red colors if you're really confused.
Yeah. Well,
all right, so when the slides show up, I'll let you know when you can start. Go and do a dance, come on. I've been entertaining people for 2 days. Apparently he does not have your slides.
I gave them to you. You told me you received them.
All right, let's schedule the next speaker up while you guys work this out.
Let's change, yeah.
I didn't know I needed to get We'll swap around. All right, so it was Joseph, right? Yes. Good, my brain isn't that completely shut yet. Yeah, we got the podium mic there, so
see, I wanted DVI. Sorry, DisplayPort. And this should work.
Should work.
I set it up earlier today.
Yeah, there we go. It does work.
Awesome.
All right.
Okay. Can you all hear me from here?
Yes, they can all hear you. All right. So you ready to go?
I am ready to go.
Well, then start. You're off.
So yeah, hi everyone. I'm Joe Wakeling, also known as WebDrake. And about 2 years ago at DConf Berlin, I made an announcement about snap packages for DMD, DUB, and LDC. So this talk is to basically update you on what's happened since then. So first thing, if you don't know what snap packages are, they're an approach to universal packages for Linux distros. So you should be able to install them anywhere, whether it's, Ubuntu, Arch, SUSE, pretty much anything you like. You can find out about them at snapcraft.io, and there are instructions for installing the snap package daemon on whatever Linux system you wish to work with. There is currently still a package for DMD, which covers multiple releases all the way since 2.076. For DUB, where we just have the latest stable version always available. And for LDC, which is, I think, every stable release since about 1.1. And what this means practically is that on any Linux distro where the snap package daemon available, it's super simple to install. In this case, I already have it installed, but for example, I can, if I want to, switch between any minor version of DMD, and it will just download it and install it. So and not only that, but it will keep me up to date with the latest version of this minor version. So if a 2.080.1 goes out or whatever, that will automatically go up. So this thing will auto update to you. I can, for example, switch to, let's say, 2.084 if I want to, but I could also switch to just say, give me the latest stable version of this thing. Or for example, I could say, give me the latest bleeding edge version, which is 2.086. So if anyone wants to try this out now, I would really appreciate it if you would try out this latest 2.086 version and tell me if it works. So I started putting these things out probably, more than a couple of years ago now. I didn't get a lot of feedback from people in the community, so I didn't know, but about October last year, I put up there was a little notice put up on the downloads page on dlang.org. And then something happened, and I didn't notice this until the beginning of this year because I wasn't hearing anything. But there's now about more than 5,000 users of the DMD package and almost 5,000 of the DUB. What's slightly worrying is that there's only about 50 users of the LDC2 package, and I think that's because LDC2 is not mentioned on homepage, so it's going to go there. The other change that has happened is a wonderful person called Ernesto Castellotti showed up on the Snapcraft forums, was also interested in doing snap packages for D language tools and projects. More about him on his homepage here. And he has got in preparation not only is he helping me keep DMD and Dub up to date, but he's also got in preparation a whole load of other snap packages for various tools. So this is all where Nest does work. The only reason it's not published right now and available for you is a small bit of bureaucracy that we have to go through to make this happen. And when that happens, you'll be hearing an announcement. So please give a thought to using these tools. They should be very helpful on pretty much any Linux distro. And yeah, that's it.
All right. Do you want a quick question? You got about 30 seconds. Quick question. All right, very quick. We got 30 seconds.
Just a quick one. Those active stats. Is this thing phoning home to some server and telling the server who's, the number of users that are active?
So I'm not entirely. I think it's going by how many auto updates happen. So by default, it auto updates. Oh, yeah, sorry. By default, it auto updates. But you can turn that off if you are paranoid about who's listening to you and only update manually.
All right, well, round of applause again. And it looks like we got Nicholas now.
All right.
And you're also ready to go. So just give me the thumbs up and I'll start the timer.
How do I scroll this? There we go. Good. All right, so as you probably know, we're having an AGM. The agenda is here. Please have a look at it. Please discuss it, because the more we discuss before, the more useful stuff we can get done. Now, so on to what I actually want to talk about, which is repositories. D-flat, which is a C# .NET wrapper that I've written over the last couple of months. It's rather alpha. What it is a C# application that reflects on a DLL and dumps a bunch of static methods so that we can call it through the core language runtime. Unfortunately, this only runs on Windows because you can't save generated DLLs for God knows what reason on a non-Windows platform. So what that allows you to do is to call, where am I, test. That's not what I meant to do. Let's try that again. Is to write code that looks like this. So we declare some C# namespace stuff with the function we want to call. There's still a bunch of test code in here because I have fun on Windows trying to get stuff to work. But that's so class driver is the name of the library we want to reflect on and generate stuff from. We create the host with that. Currently, we create a wrapper for that using, it's a class at the moment, but that's going to become a struct. Anyway, we can call that, and it works. We can call C# static methods through that. The unpin there is because C# has a GC, and we have a GC, and two GCs don't play particularly nicely together. So currently the strategy is to, when you want to call a C# method, disable the DGC, call the C# method, and then re-enable GC on the other end, so that you don't get horrible bugs. There's some notes on why this is the case here. This was mostly just me dumping brain dump of what problems you will have if you don't do stuff properly, and a note of the current strategy of how things need to work. So what this will enable is completely horrible performance of calling arbitrary C# code if you want to iterate rapidly and you have some code in C# that does what you want to do and you just want to use it and don't care about performance, because that does lock the GC every time you call it. That's about it. This is very alpha. This will change quite rapidly soon, but it does work. And yeah, any questions?
Yep, raise your hand if you got one.
No questions.
Looks like you're all good. Round of applause for Nicholas. All right, Amory, round two. Oh, look, your stuff's ready now.
The previous one was pretty good.
All right, are you going to stand at the podium or do you want a mic?
I don't know.
Well, we've got options, right?
Yeah.
So if you're standing at the podium, just speak into that. Otherwise, we got this one.
Okay, I think I'm fine. Everybody can hear me, right?
Alrighty.
Okay.
Yep.
So I'm gonna stay
Then
there.
off you go.
Okay, so I'm Maurice Sechet. I'm the lead developer of Bitcoin ABC, which is like a cryptocurrency software you don't need to really care about. I've been in the D community for a fairly long time. And today's topic, I want to, make a bit of a problem statement of what I'm not using D more for what I'm doing, and then more problem, and then, that's a lot of problems. So I'm a lead dev of a large application, large-ish. I mean, they are bigger than that, but it's about 200,000 lines of code. It's not exactly modern C++, but it's C++ anyway. It takes, like 1 hour to compile from like a fresh compilation, so it takes forever. There are serialization, deserialization stuff. For anyone that have done that in C++, you know that it's probably preferable to poke needles in your eyes. It has a lot of multi-threading, same thing. This is awful. So DMD would, look like a very good option for me. It's a system language, and I need that because I have cryptography. I need to avoid side channel in all the crypto code. So that means I need to control what I'm doing with the cache and the branch predictor and stuff like that. I can only do that with a system level language. And I also have low latency constraint in some part of the code. And so I need to be able to control things a bit tightly. It has very fast build time. It has a type system that helps me with trade safety. It has also, like, for deserialization and deserialization, because of introspection, you can go crazy fast. I mean, like, I implemented the whole protocol that we have in less than a day just by implementing like a set of function, like, you serialize, deserialize an int, and whatever we have else in the protocol, a vector, and then a bunch of struct, you reflect on them, and boom, you have the whole protocol implemented in less than a day. So that seems like a great stuff, right? But I've only been able to use D for like prototyping, simulation, doing various measurements, stuff like that, but not in the core application. And this is because I have challenges, and they pretty much all fall in the same category, and that category is like weird shit, right? There is weird shit happening all the time with D. So it's not like missing features and stuff like that. Like, people are talking a lot about new features that they need, and I have everything I need in D, right? But most of those features, they're like 95% there, and then the remaining 5%, this is the twilight zone, like stuff appear in there, disappear, like, I don't know, nobody understand any of it, like immutable enums and stuff like that. So we started calling that weird shit because this is very weird. And I want to go through a few examples. So we have compile time feature, they are great, right? But we have like language construct, like static if. We have a stud trait that does like half of the thing that you need to do and not the other half. And then you have like a bunch of very bizarre compiler thread that like none of them works consistently. And what is that, right? Like, it's very complicated. Nobody has any idea what, like, we just like copy paste recipes that we have, just like the C++ guy do with templates, and like they unwrap this 25 different series of templates to do whatever they need to do. Okay, so we have type qualifier, they are great, but we have shared. Apparently, the only thing it does is prevent you to increment plus plus, but you can still do plus equal 1. So you cannot construct any of them safely because you need to construct them thread local and then case them to shared. This is what the spec actually tells you to do, but this is also the spec that tells you this is undefined behavior. And so as a result, it doesn't provide very much guarantee in the type system. So what is that? They support profiling and code coverage out of the box. That is awesome. This is the kind of stuff I need, right? But all the file format that it dumps out of it, they are not like standard file format that is supported by other toolchain. I can use none of the tools that exist, like gprof and like whatever is my IDE and stuff like that. So what? The unit test, D has a unit test block, and this is, honestly, this is the best unit test feature I've seen in any language, especially because of the way it pairs with the way visibility works, like public and protected and private and all of that. It allows me to test a bunch of stuff, and in other language, I have to build weird scaffoldings to be able to test what I want to test. And this is like, honestly, this is like the best feature ever, right?
30 seconds.
The test run before main. Like, what is that? Right? I don't want to run the test and then my application at the same time. There should be like two parts of the build that are different. Okay, we have like optional Node.js. Maybe I have 30 seconds, so I'm going to go fast. It's like there are some weird stuff in there as well. Okay, so I really want to use D. Like, you guys need to save me from C++. This is horrible. There is like even more weird shit in C++, but I don't need new feature. I need like.
And
this
that's
to be
it. You're
bigger.
done. Thank you, Amaury. All right, and we've got our GCC hero, Ian, stepping up to the stage. I'll make him feel welcome.
Okay.
All right, let's have a look at your setup here.
No.
Well, it's an adapter. Just pull it out now. You HDMI.
Excellent.
Yes, excellent.
It's just what I like. So.
Yeah, there we go. Should be getting something on screen. There we go. All right.
That's not what should be on screen.
No. Over there, yep, just full screen it. You'll be good.
Oh, excellent.
All right, excellent. So, ready, set, off you go.
Okay. Now, this here is a mobile phone. And let me just log into it.
I know that.
So, yep, this is an ARM64. How many processors have we got? 8 and 3 gig memory, 1 gig swap. Yeah, we have a compiler here. One. And yeah, that tells us pretty much information that we're looking for. So AR64. Let's run the test suite. After a while. And we're passing. Now, I'll stop this in a minute before my phone dies, our battery. But yeah, pretty much, so this will actually pass all to completion, 100% passes, no problem there. Pretty good, although very little that I actually did in order to actually achieve that. It was sort of very much, small bits and pieces here and there. Excellent, you're on the wrong screen as well. How do I move you? I can't move you. Let's do you this way. So yeah, it's really small things that were really sort of very things in the D runtime to really sort of get this sort of stuff working. And as I was porting various architectures, this sort of stacked up, and it's just a couple of lines here, a couple of lines there. Really just sort of show you sort of a few examples, sort of question and answer session. So what do you think is the problem with this function? Yep, Stefan?
The stack grows in the wrong direction.
Yes, on when the stack grows up, pthread get stack is already at the bottom, so there's no need to adjust it. So we add version stack grows down, adjust. Next, why would this assert fail?
Endianness.
Endianness, yes. On little endian, HELO is on the left-hand side. On big endian, it's on the other side. Next, why would this throw a SIG bus? Alignment, indeed, because, well, on 32-bit platforms, well, mutex is a class, so that alignment is wrong, and the pthread may require alignment of 8. So you might get lucky on the locks, and the first array is on the correct position, but the second is not. So again, fix would just be to have 2 separate global with the correct class instant alignment. Next, why would this seg fault? The external API accepts a void. The internal is actually a struct. So while on x86, void pointer and struct with a pointer are passed in the same way, on some architectures, they're passed differently. Next, why does this have silent corruption? Yep. No. So the for each body is turned into a delegate. Remember, for each int I. This calls this function, which uses size t, and passes the size t as a pointer. Now on Little Endian, all the bits are on the correct hand side when it gets truncated. On Big Endian, it's on the opposite side, and so the index here is always 0. The compiler should warn about this, and it does for
30
static
seconds.
arrays. And finally, why would this say fault? Strict alignment. That's kind of a workaround, but you kind of get the idea of what's going on. Now, currently in GDC, these are the targets that we support. This is what I want to extend to in the next point release. And these are various, when the came out, these are the compilers that I...
And that's time. Thank you, Ian. All right, so we got Leo coming up, right?
Yeah. Let's see if this. Okay. Can you guys
ready
read
to
it?
go?
Yeah.
All right, then we're starting.
I'll show. Got a few questions about Nix, so I'll show you how I use Nix. And the first thing I'll show is how to add Nix packages to your local path. So nix-env-i installs a package, but only to the local user in the path. So I'll use dir-env. Anybody familiar with dir-env? Yeah. So dir-env is awesome, especially with Nix. So you can say, well, I show you first. I have nothing up my sleeve here, right? So I'll say I want to use Nix. I want to have dmd, dub, and dub to Nix. I create a file rc. Now dir-env is complaining that the file changed, so I allow for this folder. Oh, that is a good one. I'll remove this guy. So dir-env, as soon as you go into the folder, the env-rc file is interpreted, and now I have dmd and dub in this folder. If I go out, I don't have them anymore. That's good. Let's create a 5D project. Everything default sounds about right. So now I can build this. Okay, that works. But now I want to create a Nix file for that. I'll show you later why. I'll do dub to Nix save. It prefetches all the things from the selections file. Prefetching because it needs the SHA-256 for every package. It's not happy with just the version number. So it prefetches a lot of stuff. Okay, there we go. So now what we have, this was a failed, we have a dub selections.nix, and we can actually use that thing. Let me also, actually, I should have done this. Okay, it fetches again. It's not to just have the dependencies. I also want to have the skeleton for the actual application. So with the -o, it creates a Nix file for the actual application. The Nix file is fairly standard. It just imports the local folder and make a dub derivation for the folder I'm in, and I can build that. So I do build default Nix. Aha, so now we're getting somewhere. It fails, and why does it fail? Because the build process for OpenSSL for 5D TLS tries to write in the Nix store, and that is not possible, right? Everything is immutable. You're not allowed to change stuff inside that store. And why is that? When you want to use 5D TLS, it tries to find out what version of OpenSSL you have. And then during the build process, it does an OpenSSL-v and creates a D file with that version in it. But we cannot create anything because that's not deterministic. So we'll tell it to stick to one particular version by using a subconfiguration. Forgive me if I don't align everything. Why am I doing this in Vim? I don't know. Okay, so we try it again. Nix build. And what Nix build does, it tries to build and then creates a result inside the local folder. Let's see if this works now. This is not the most exciting lightning talk like this. Anything else? Well, I can switch to another thing while that is building. Sure. Oh, time seems to go way slower when I'm up here. Okay, so it fails.
30 seconds.
That's what I thought. It's failing because we're missing one dependency, and so we tell Nix that we want OpenSSL, but OpenSSL comes from another thing, and that is from the official store. So we need this. And this would result in a proper build, but it takes too long. So what I show you can add any native dependency.
That's time. Thank you, Leo. All right, we got Razvan stepping up to the stage again. Did I mangle that?
Yeah, that's okay.
It's okay. All right, thank you.
So do I have to stay here? I can't walk away from the
If you want a microphone, we can get you one.
Yeah, no, it's fine.
Razvan, there we go. So this microphone also works, I think. Oh, pretty.
Okay. Oop.
When did you paint that?
Yeah, I don't need it anyway, so.
All right, so you're just going to talk, no
Yeah,
slides.
Can I have them?
All right, is this one on? All right, we should be on. Can you hear me? Nope. Sounds like we need some volume still. All right, that sounds like it's working. Your time starts now.
Okay, so first of all, I'm here to talk in the name of the group, D-Lang group from University Polytechnic of Bucharest. So we've been attending DConf for about 3 years, and absolutely every single year we heard talks about how to raise the popularity of D. Usually when we talk about this, we have two perspectives. The one is that what features do we need to add? What features do we need to improve so that we raise the popularity? Well, we agree with Omori. We already have a lot of features that are working okay. So if it's popularity that we're interested, that's not the right perspective. The other one is marketing. We always talk that we need more marketing. Rust has marketing, and look, everybody knows about Rust and so on and so forth, but we don't have the money. Okay, so we don't have the money. We've hit a brick wall. Now, I'm here to present a different perspective, a perspective that we all adopt in Bucharest. Now, since we are all educators over there, teaching assistants or professors, we kind of have this motto that get them while they're young. So, yeah. I know that didn't sound right, but. So the thing here is that we want to try like this reverse strategy. And if we let people know when they're young about this cool language that we like, maybe they will remember, and when they get hired and they're in the situation that Attila was, now that they have DPP, they can push D. And I know that it's kind of a long shot, but what other alternative we've got? So in order to support this, we've been constantly trying to push D to students. So yeah, that doesn't sound really well also. So we've had some projects. Alex also was is doing his bachelor thesis on this. And anyway, what I was trying to do is to announce that this year we're holding a D summer school at our university. We want to take like 40 students and show them the wonders of D. And I think that if you guys, wherever you work, and try to support D for the young people, then maybe that's a strategy that will pay off in a few years. Thank you.
There's plenty of time if anybody wants to ask him a question. Nope, he doesn't want to answer. All right.
Any?
All right, I think we can save those kinds of questions for beer conf, hey? All right, give it up for him again. All right, so now we've got our last talker coming up by the name of James.
Hello.
And you don't have slides either?
I don't. Thank you for everyone for putting
All
me in
right.
such short
All right.
notice. You'll have to
Let me get the timer ready. And go.
Thank you. You'll have to imagine the best slideshow you've seen today. I'm James. I've spent a lot of time over the last 6 years working with Dee on a number of satellite data processing projects. There is a very interesting kind of satellite data that allows you to track the movement of ships on the oceans. It turns out global shipping is basically a massive IoT network. Ships talk to each other using a machine-to-machine VHF, VHF radio communication system, which they yell, "This is who I am. This is where I'm going. This is what I'm up to. This is what kind of cargo I'm carrying," to help captains avoid bumping into other ships. It's a safety of life system, and it was discovered quite recently that the signals can be picked up by a low Earth orbit satellite. So various companies have been filling the sky with constellations, and nowadays you could, if you pay the right people the right amount of money, you can get lovely real-time feeds of kind of order of 50 million messages a day broadcast from all over the globe. And we've moved in a fairly small number of years from a situation where we had no idea what happened on the sea to a really very strong idea. Problem is the engineering, the work to translate this data into useful knowledge is quite challenging. And as the field is so young, it's often rather badly done. So my users, my clients have been primarily in two groups: scientists who want to understand questions like where does the fishing in Europe take place, because it matters, for example, for governments who want to plan things. Or the second group is forensic analysts who are interested in crimes that take place on the sea and want much more interactive tools. But both groups want they both want to do data science, but some of them also want tools with much better latencies. The traditional way you do this is by throwing it at Hadoop. Turns out writing Spark jobs for this kind of data is very hard to do. A lot of money gets wasted. A lot of money gets wasted on teams that produce systems which produce the right result, but run for kind of weeks and weeks doing not very much. So after a certain amount of time helping people do this, you go, a much better approach is to attack it with efficiency rather than parallelism. The data rate, the data volume, it's kind of in the tens of terabytes range in uncompressed JSON. So it's in that netherworld but it isn't quite big data, but it's too big for standard tools. So you ask yourself, if we want the productivity of Python and we want the performance of C++, is there a language that can help us? D turns out to be an absolutely perfect fit. It's a kind of bizarrely perfect fit, actually, because everything from command line batch processing to where you just want to do a job as a one-off thing, to building infrastructure that can serve up reasonable number of queries with very, very good performance. D slots in perfectly. The most interesting work, the work that really stands out as a result of the project, is that if you want to build, this is a time series problem. You get all these messages, you project them into a series of representations, each of which captures one essence of the kinds of questions that your users want to ask. So, they might be interested in the way ships move, because that tells you something about the way they do. You basically do ML of that. They might be interested in where they go, because you can pull up patterns of which companies are interested, touch with companies. And you do this by projecting the data into highly optimized, essentially special purpose databases, which you write with very specific data models and chunking and ordering invariants and particular indexes you write. And you memory map all of that. You say take over a 2 terabyte SSD, that kind of thing, and you memory map all of that and get out ranges of spans of memory map data. which you then put to long chains of range processing, which is what D is wonderful for, and it works beautifully well. It's sort of embarrassing, actually, the amount of correct code, the amount of correct behavior you can get from a very, very small amount of really very beautiful code, most of which has come from the standard library anyway. And you've just added a few more generic algorithms. Your storage engines kind of...
Sorry, 25 seconds, by the way.
Thank you. Yeah, anyway, so you use the metaprogramming design the storage engine to make that cheap. So as users come to you with different kinds of queries they want to be able to run fast, you can materialize the databases they need to do that quickly. Then you run generic algorithms over them, but you get to reuse the algorithms because it's D.
Wow, that was a certainly impressive compression of your talk there. Congratulations. Thank you. All right. Yeah, I'll take that. Okay, and that was the last of the lightning talks, which consequently means the last of today's talks and the end of the second day of DConf. So please give all the talkers again today a round of applause. Yeah, all right, pat yourself on the back. Attila. We'll enjoy that. Okay, so well, we got to get out of here by 6 o'clock again tonight, so don't loiter around for too long. Go out, feast, drink beers, be merry. We're in London. Same place as before. It's still on the it's still on the DConf website. In the venue down the bottom of there is all the details about the pub that we have a room booked for. So come along, and thank you again. Enjoy.